once instead of late. And the internet is holding stable. So hopefully you guys can actually hear me, and it's not going to be a fucking nightmare again, whether the second I start streaming, the internet collapses. It's a somewhat cloudy day, but it's not raining, which seems to fucking kill Starlink for some reason. My application did not like that. Hello, welcome to whoever joined into the Discord. Be aware, I am streaming, so.
Hello.
I am working on a Reflect Serializer deck, so that should be fun. How have you been?
I don't know, I've been alright. I had an interview today.
So you're really quiet. I can't actually hear you over the background noise.
Oh, let me switch to my phone actually.
Okay, cool. Why did you not compile? Cannot find function. Color. Oh no, what have I done? I've broken something. Why are you complaining? We're bringing the whole reload. What do you mean? Cannot find. Oh, because I checked. Right. Yep, got it. Okay. So these all must come from something. They're coming from a feature. That's what's going on. So when I run the example has the feature enabled.
That'd be a lot better.
Yeah, that is a lot better. Whatever you're on before, I couldn't hear you over the background noise. Like I could tell that you were talking, but the noise meant that I couldn't work out what you were saying.
Oh, it's probably because of the fan.
Yeah,
I was on like a fancier mic that picks up everything. I forget the fan is like overpowering my voice.
Yeah, it's also sometimes a me thing in that like when my head's not in the best space, it's that like I can't hear, like if I'm watching a YouTube video and then like I'm in the passenger in the car, I can't hear, like my brain does not pass what is being said if there's that rumble of the car. So it's that kind of like, it's just enough background noise that my brain can't pick out words. It's like I know that you're talking, but I can't understand any of it.
Yeah, I just said I'm doing all right. I had an interview today and that's all I really did.
How'd
I
the
played
interview go?
Minecraft with a friend. I guess that's the other thing I did.
Did the interview go well?
There's gonna be a follow-up one, so I'm assuming it'll
Oh.
go okay. I'm not looking forward to it because I kind of don't want to go into marketing, but I don't know what else to find at the moment around where I am.
Fair enough.
So
yeah, that's kind of me at the
like,
moment. Where I'm going, I need a job, but I'm like, I don't know what to fucking do. And everyone just keeps going, oh, we'll just get like a job at like Woolworth. I'm like, no, I just want to go work at a shopping center just because everyone goes, I need to have work.
yeah. I think I used to work at like a sandwich shop for a while, which I honestly kind of miss that because I get free sandwiches.
I don't like people enough is my problem, because everyone goes, oh, but it's an entry level thing. I'm like, yeah, but like people complain when I know them and I act the way that I do, and you think that I can deal with some fucking person who's stuck up and entitled and thinks that because they're buying some cheap item off me and the store that I'm at is paying my salary, that they can treat me like shit. Like I am not, I would not take shit from that. I barely took shit from my boss that was paying me reasonably.
Yeah, that's completely fair. I kind of just have like, I don't know what you call like a customer service like mask, I guess.
Yes, yeah, I'm the opposite. Where
you just
I would be perfectly happy helping people with their tech problems, but fuck me, would I still give them a lot of snark and sarcasm, because I'm like, what the fuck do you mean? like it does my head in when my mum asks for help and I'm like, and she goes, oh, but you know how to fix this. I come over and I read what's written on the screen and do what's written on the screen. Like it's popped up with like, oh, do this. And I'm like, I do that. And she goes, see, you know how to fix it. I'm like, no, I just read the pop-up. Like I did not know how to fix this.
Yeah, no, but there's so many people that come up to me and like call me like a tech whiz, and I'm like literally stupid.
Yeah, it is one of those
Like,
things that you notice with older people is that like we seem to have just an inherent sense. Like my dad asked me how to do shit on his phone, and I'm like, well, there's only like three things you could possibly do on your phone. You either tap it, you tap in a hole, or you click like the three dots. Like they're the only three ways you can interact with anything on your phone. So if you try those three things, one of them will do what you want it to do, or it can't be done. Like,
yeah,
one of the few things that I actually think like Apple got really right was the gestures on their touchpads. Like when I had a MacBook, like the fact that you could zoom in and out with like just like the right finger gestures on the touchpad was phenomenal.
oh yeah,
Except when it did it by itself. Like it was infuriating when you were trying not to do it and it did it, but like it was so nice when you were like in that headspace to be using it and you're like, oh yeah, it just does what I want it to do. But the second you weren't thinking about it and it starts doing it, fucking drove me spare.
yeah. I I I like the three finger gesture where you just slide everything up and you can see all the apps.
I don't remember that one. I remember you could do it's like pinch out would zoom in, pinch in would zoom out because it's like intuitively like you're grabbing and making it smaller, like physically made things smaller on the screen. You could do. I thought the three finger one was like a zoom, but like to the center of the
Three finger
screen.
one
Or
just
something.
like puts everything up, like on, just gets every single app that's open and then
Like
puts
the
it
alt
on the
tab.
screen smaller. Yeah, kind of like that.
I
So
haven't
just
used a
like
Mac since 2016, so
I'm on a Mac right now. I actually didn't switch to my phone because I was like, I can just use the Mac.
yeah.
Like, it may be better because then I have a bigger screen and then we can look at the stream.
Mm. I've been wanting to work on your game stuff, but I don't really know what I'm doing, and I feel like every time I try to touch it, I just end up
It's okay.
fucking around doing other shit. Like I don't know if you watched the bit of stream that I did where I tried to set up the toolkit, and I just ended up spending like an hour fucking around trying to do like a soft body physics thing.
That's cool.
I thought it would be really cool to have the slime be like four balls that are like linked together by springs, and so like as it moved around, it would squish and squelch, and like you could do the soft body, but like I just couldn't get it to work. It just would spaz out, and also the physics engineer I was using kept yelling at me for making loops.
Hmm.
I know you can do it, I just don't know how to do it. It does my head in.
Yeah. I've been. I've just been looking for a job recently. It just kind of sucks. I don't know if I want to talk about like personal stuff on here, but yeah, I've been not doing too great. But I won't, yeah, went on about whatever. I just wanna just
I
hang
know the
out.
feeling. Like I haven't streamed like all last week because I've just been going through so much fucking shit dealing with everything at the moment, and it's just like I really don't feel like going upstairs on my computer because it does kind of feel like a lot of when I stream for 12 hours in a day, I'm avoiding dealing with the other shit. So it's kind of feel like you know got to make sure that I
Yeah,
don't have anything else to be doing and that I'm not just hiding away. I did find out the other day that I've gained a new YouTube member that's paying me to do YouTube now. That I'm like, wow,
oh,
that's cool.
nice.
Except YouTube didn't tell me about it, except to say, hey, maybe like raise the price of your membership for everyone. I'm like, why?
That is crazy.
They keep trying to push me to change my prices, and because to reflect the new like economic situation or something, and it basically results in me increasing the prices on the rest of the world and lowering it for America. And I'm like, why? How does that make any fucking sense?
That does not make any sense.
Even more confusing is it says lower all the low end stuff, except in Taiwan, raise that one, and raise all the higher tier ones. And I'm like, nobody's even in the higher tiers. Why would I make them more expensive?
Yeah, that doesn't make any sense.
It confuses me.
Yep, my phone. Around here.
Honestly, I'm not entirely sure what I'm doing. I had such a clear image before I started the stream about what I wanted to do, and I'm like, now I've got here. This is why I'd write to fucking to-do lists, is because I just go like, what am I doing?
What is a reflect serializer? I'm kind of unsure.
So in Bevy, there's because it's in other like languages, but usually it's built into the language. Like Java has just built-in reflect, but Bevy built on top reflect, which is the idea that you can interact with the type system at runtime rather than needing to know at compile time what the type is and how to interact with it. So you can do things like access fields by name rather than like the compiler doing its compiler thing. You're actually passing a string and it knows how to convert that into where in memory to grab the value from. So that's reflect, and it's the idea that you could like build a type at runtime, or you can like interrogate a type. Like someone could pass you a pointer, and you could actually like, knowing that at the other end of that pointer is a reflected object, you can like work out what fields it has and what types those fields are. So a reflect serializer is just a way of turning any reflect object into like a file and then back again, without needing to. Without the programmer having to explicitly say, "This is how you turn me into a file and back again."
I see.
Yeah, so the idea is that like Bevy will say, "Oh, this is an integer," and I can go, "Oh, I know how to serialize an integer, so I'll serialize it." But then it might go, "Oh, but this is a vec3," and then you go, "Oh, okay, I don't know how to do vec3. So like, what's inside of vec3?" It goes, "Oh, it's 3 floats," and you're, "Oh, I know how to serialize floats." So you serialize 3 floats, and the idea is that you store like the name, like it's a vector, and then the data, and then so when you go to deserialize it, you can look up and go, "Oh, it's a vector," and Bevy tells me that a vector contains 3 floats, so I expect the next piece of data to be 3 floats. I've done it before, but it's like one of those it's like one of those really complicated things, because to make it look nice, like Bevy has sort of a built-in one that just literally serializes everything as its full name, and like it's so dumb because it puts like full path lengths and everything, and it's so hard to read and not human editable. And I'm kind of going like, it's about making sure that you don't hit what's called like redundant path or duplicate paths. So the idea is, if I have a transform and you have a transform, then we have to declare like the crate that transform came from as well, and you have to declare the entire chain. You can't just declare like a little bit more. So it results in this thing of like Bevy by default will just put the entire crate module path all the way to the component rather than like just the component's name, which theoretically is the smarter thing to do if you're trying to make like a automated system that just saves and loads things, because it means that like you don't have to worry about conflicts where like you declare a transform and then someone else declares a transform and now they collide. But I don't like it because it makes it impossible to edit, because you need to know the exact path of everything.
We should probably just start picking up Rust. And I need something to do because I have too much free time at the moment.
I 100% recommend picking up Rust. It is very fun, in my opinion, but it is one of those like I watched a video talking about like Go, and they don't like someone saw me in chat. Bevy is trying to fix it. They're introducing like what they call scenes 2.0. So at the moment they've scenes 1.0, which does what I'm talking about, where it's like it serializes everything by really long names and it's really verbose. They're talking about making a scenes 2.0, which is going to fix that, but it's going to come with the editor. So who knows when this is going to happen, because they've been talking about doing the editor for like 2 years, and they're saying one of the biggest blockers for the editor is getting the scenes into a state where a human might actually be able to edit one, rather than this thing of like you can only export and re-import a scene. You couldn't like write one by hand because it's just so verbose. So I forgot what you were asking, something about learning Rust. Oh yeah, so I was watching someone that talked about like Go, and they don't like what's happening with Go, because Go used to be a simple language. It used to be like Go did what it did and nothing more, nothing less. And now Go is like half-arsing adding the other features that other languages have. So it's like it's not doing it to a level where you'd want to use Go because it has this feature, but it's also complicating the language to a level of like, now it doesn't have that one thing that was Go's selling point, which is every single person does it the same way because there's one canonical way to do it. Now there's multiple ways to do it. And so I just thought that was a really interesting thing to, with like, Rust has very opinionated ways of doing things, but it means that like, there's lots of ways to do things in Rust, but there is usually a like what they call idiomatic way. Like there is this is the Rust way to do it. And then you can tell when someone didn't learn Rust as their first language because they do it differently. Not that doing it differently is wrong. It's just one of those interesting things that you notice where it's like you can see people that came from C and people that came from C# because they take two very different approaches to dealing with certain things.
Mhm.
My only issue with recommending Rust for you is you were saying about you have like limited memory on your computer or something.
Well, I don't anymore. I have my desktop finally set up.
Oh,
Actually,
okay. Well, in
in
that
a
case,
living
yeah.
situation.
The biggest issue
I'm in
I
a living
have
situation where I can
found with
set up
Rust
my
is that
desktop.
if you're like me and starting new projects all the time, each project is something like 60 gigabytes because like it compiles everything. So you end up with this massive pile of like build dependencies and stuff like that. Like we'll just go into like reveal and explorer and we'll just see what size this is. So this is my inventory crate that I'm working on stream. And if I go to properties, it's 30 gigabytes. And if we go into the actual thing and then go just what Rust said so that Rust can compile, Rust is 30 of those 30 gigabytes with Rust compiling everything. It's in the rest is like a rounding error. So it says 30.2, and if I go up, the rest of the crate, okay, maybe do that by going like this and go. No, then it's wait. Is that? Yeah, so the rest of the file. So the actual project is 1.2 megabytes. The build artifacts is 32 gigabytes, 30 gigabytes. So Rust makes a lot of artifacts when it compiles. So if you have multiple Rust projects, you can use up a lot of your hard drive just on build artifacts that you've got to clean it up all the time. I think I even made a custom tool once that would like scan through my entire hard drive looking for the like really obvious like cargo.toml with a target folder and delete the target folder because if I haven't worked on a project in 3 or 4 weeks, then I'm probably not going to be working on it, and I can deal with the extra 5 minutes it takes to recompile it when I go to work on it next, rather than it taking like 30 gigabytes of hard drive space. So I'm assuming with your desktop, you can actually compile in a reasonable time as well.
It's like an old gaming computer from when I was in freshman years, like 22 now.
Yeah, so that's not going to be too bad. I think I had someone come into the stream on like a 2014 laptop complaining about how long it took to compile and that it was really, really slow once they did get it to compile. And they were trying to ask me for help. And I'm like, I don't really know what's wrong because for some reason it like wasn't using their embedded graphics card. It was running the graphics on their CPU, so it was like only getting like 10 or 15 FPS. And it's like I legitimately don't know how to fix that because that laptop is so old that like Bevy is really good at detecting the right thing. So like I wouldn't know what to do.
Yeah, I think I remember trying to like compile Bevy on like the older, not the older laptop. I guess I was using a Surface for a bit. My partner lent me one because I didn't have my MacBook until more recently.
I'm just going to answer this person's question. Rust has the ability to do dynamic linking, but I don't remember how like well it works, and I think it's not the easiest thing because of the Rust doesn't like foreign foreign objects or something, or FFTs, which is the idea of like calling into something that's not Rust. So the idea is that you're supposed to like wrap the binary in a like a interface layer that you can then call if you wanted to use like a precompiled C binary. And so it results in this thing of like almost every Rust project uses crates, and crates has all the code. So it literally just compiles from source all the way up because it's just not how the ecosystem works. Like it's not that you can't, it's that the ecosystem do that way. Bevy specifically has a dynamic flag that you can turn on that lets it link dynamically, which is like for building, do it this way because it means that you also would have to share the bevy.dll, and they're saying like what you do is when you're developing, you'd use it that way because it's faster to link into a dynamic than it is to statically link. And then when you finish your game, you would then build it normally to build it all into one exe rather than having to share the bevy.dll. Yeah, Reflect is really cool. I I love doing stuff with reflect because there's so many cool things you can do with the recursive nature of reflect. Of like you can reflect the internal parts of reflect, which means that like when I did this last, all I needed to implement was like the specific reflect for like entities because I wanted them to be viewed differently. It's only if I specifically wanted them to look different did I have to implement anything, because once I had the recursive logic, you can build literally everything in Rust out of the base like 6 types or whatever it is. It's like you have the different int type invariants, the different float variants, strings, and booleans are like the built-in type, and char I guess would also count, are your built-in types. And then Rust, not Rust, Bevy has some specific ones that are like you'd want to handle these differently because they're not really types, they're like pointers basically. So like things like entity, you'd want to serialize differently, and also theoretically you wouldn't want to serialize entities at all because entities, the way I do it, I think you serialize them relatively rather than absolutely. So it's not like you serialize entity 68 to 68. You instead say entity 68 is now entity 1 in this file, and then anytime I see entity 68 in the world, I convert that to the local, because it means that when you convert it back, you can know that they're actually like referencing this. It's like, oh, every time I see entity 1, it's the same entity. But what entity it ends up being when it's deserialized doesn't matter. It just has to be the same entity for all of these. So entities becomes a number, and handles, you have to do extra little logic because you can check to see if it has a file, and then you can serialize the file path. But if it doesn't have a file, it's like, how do you serialize that it doesn't have a file? So I think the way I went about it is, because you have access to the world, you could go in and you could say, hey, this was like a dynamically loaded entity. It didn't come from a file. I'm going to serialize the other end of the handle and then give it an ID saying that like within this folder, there will be a section of assets, and asset 16 is the asset that this handle is pointing to. So you'd be like, oh, this is asset 16. And then you could go, when you go to spawn the world back in, you go, oh, asset 16, and you go and load that from, later in the file, basically. So you would be able to like say, oh, this one loaded from a file that already exists. I'll point to that file. Oh, this one doesn't come from a file. I'll try and serialize the asset so that it's accessible from here. You can do like really cool stuff like that, but like it does take like the electrical work to do it on things, and you run into certain issues like technically every asset handles a different type, so there's no easy way to implement it like broadly, but you can do some cool stuff. I also have absolutely no idea. I've never done a proper serializer before. Usually I cheat and I just implement like a function. So you go like component serialize, serialize, and it does its own thing. But we will learn today how to actually do a proper serializer. So the tests are going to be that I need to say something like, I forget what the rules are for like RON. I'm gonna look that up. RON format. Because what I want to do is copy the RON idea of being like example in JSON, same example in RON. So RON seems to wrap everything in like a type declaration. So the very first thing in a RON file is the type being declared. Okay. That's fine. That's good. Interesting. Okay. So I guess we go start simple and say type OK. The fuck does type OK mean? What? Type, no, I get that that's what you are, but what is OK? No drop. The output type provided by the serializer during successful serialization. Most serializers that produce text or binary outputs should set OK 0 and serialize into IO write and buffer containing within serialized instance. Serialize that built in memory data structures may be simplified to use OK to propagate the data structure around. Okay. So this should return like okay nothing, because apparently it's saying like when you're successful, what do you return? And if we're outputting into a file or a okay. So type error. Okay, we'll go like mod error, because this is how I like to do my errors, is have them in their own folder. Pubs enum error. Okay, and then we're gonna go here and go derive. It's weird that my fucking AI subscription ran out, so now I don't like have to type everything because it doesn't autocomplete. It's just a little like jarring to have that. Like I'm used to it auto-completing things like derive. Okay, we come back to here and we say that your error is error, so the error. Okay. The trait bound SERDI error is not. Oh. Apparently we can't do that. Okay. That's interesting. No, what are you saying? What type does this need to have? The error type, so it needs to be an error SERDI error. Okay, so SERDI. What the, wait, no, why are you calling it STD error? Saying that this error has to be an SERDI error. Okay. Is it this error? 4. So it just needs a custom implementation. And then it just needs to return self where T its display. Okay, so custom, which is just a string. And then we just say self custom format. Wait. Okay. T. So saying where T implements display. Oh, message, sorry. So you format message, and then it's saying this doesn't implement display, which is just such a weird thing. Doesn't implement display inside trait bound. So you're saying this doesn't implement display, which is incorrect. Error. Custom. Okay. Strange. Now you accept this. Okay, cool. So you're saying I am missing. Are these types? The fuck? Serializer. Huh. I guess this is why I've never implemented a serializer before. That is very. A lot of these are pre-implemented of saying they're a custom not implemented. Okay. So these all need to be implemented. Interesting. Okay. That's kind of annoying that it needs so many types. But there's serialized map, serialized sequence, serialized struct, serialized struct variant, serialized tuples trait, serialized tuple struct trait, serialized tuple variant. Okay. I guess we have to like pub struct component map. I guess I'm gonna call it component to do. And be like component to do. And so you're saying that this doesn't implement serialized map. Okay, so apparently a serializer is a much bigger deal than I normally. Yes, it would explain entirely why I don't normally do it. Serialized map for component to do. So type okay. Yeah, I'm probably gonna do that, but I'm just gonna see it says okay. Must match the okay type of the serializer. Okay, yeah, that's fine. Cool. And I'm assuming type error is gonna be the same. Ooh, okay. So missing serialized key. There's serialized entry, serialized key, serialized value. Okay, that's interesting. Is that all that it can do? Well, presumably. Finish serializing a map. Okay. Can we just implement missing fields? Okay, so there's implement key, implement that. Okay, and I'm assuming that the serialized entry is derived as being try. Apparently, a try. Okay. Serialized key, then serialized value. Okay. I mean, that's looking correct. So then we can like import serialize sequence for component to do. Type error is this. And then implement missing fields, which is the serialized element. Yeah, I don't think this is going to work, actually. Thinking about it. I feel like I'm putting a lot of work into getting the serializer to work, but the issue that the serializer is going to run into is that it's saying that everything that you pass to it has to implement serialize, and that's not going to be the case with reflect. So yeah, I think I'm wasting my time implementing Serdi at all. Well, it's worth a shot. Because yeah, the Serdi does the same kind of recursive idea, but it runs into the issue of and it's probably a good framework to go, which is that we need to serialize a map, we need to serialize a sequence. What are the other types? Because I'm going to stop implementing these because I think they're just going to be broken. But we're going to go. Can you be like implement default members? No. Okay. So the serialize a sequence and then serialize a tuple. And okay, so I'm just going to say, buckle that off. So there's in terms of what needs to be serialized is you're either serializing a map. You serialize a map, you serialize a sequence, you serialize a tuple, you serialize a tuple struct. What's tuple struct? Tuple struct is like a tuple with names, and then tuple variant I want to say it's like an enum. And then serializing a struct, and then serializing a struct variant. That's annoying, because what the fuck is a struct variant? I don't know. Hopefully Bevy's got this stuff covered. So what we would need to do is say that you need like multiple things. So you need a file. Which is T. So that's what we're going to write to. I think that's correct. Okay. So we have a file T, and then we're going to need a, what is it? It's like a type, something or the type. Repo, which is a type registry, I think. So you don't want the whole type registry, you just want like a reference to the type registry. Fine. Is it the type registry arc? Is that what I want? Something like that, because that lets me get access to all the type registry stuff from the type registry itself. And it means that I don't have to worry about fucking remember the lifetime up here. So the file and then the type registry. So I guess we can effectively get started with working out how our serializing is going to work. Again, we're trying to copy somewhat what Ron looks like. So for now, I guess we go into our tests and we go, this is a test. fn ser the, it's got like, whoop. fn serialize. Test. Oh, that's not going to work. Thank you. Can you not do that? Okay. So here's a serializer test. So we're going to go. We need more stuff too. We need to come in here and we need to go like struct test struct. So test struct needs f1, which is a u32, f2, which is a string, f3 is a what is f3? F32. So we need we could call it int stir. Wrong symbol. Int stir float bool, which is a boolean complex, which is going to be complex struct. Yep, we'll make that in a second, and then also enum v, and that's going to be an test enum. Then we go enum test enum, which is going to just have A, B, and C. And then struct complex struct is just going to have this inside of it. So the idea is that the complex struct is a way of being like, can I serialize a struct inside of a struct? Which is what the complex struct is going to do. So we need a new function that's like fn get test struct, maybe? Actually, why even fucking bother with that? Just make it default. So we need to impl default for test struct, which is going to say fn default, which is then going to say test struct. So int is going to be 10. String stir is going to be string from test struct. Float is going to be 69.420. Wow, do it the other way because then you get the full lols. 420.69, and then the boolean is going to be true because, you know, then if it goes wrong it should return false. Complex is just going to be complex struct default like so, and then enum v is going to be test enum b. Let me just call you enum b then. Okay, then again we need to actually, honestly, this one just gets default. This one's going to derive default because I don't care. So you derive default, which means I can just use default here, and then same with you. You're going to also derive default. Like only reason for thinking do default on everything is that like it means that I'm effectively saying that like there's a canonical like way of determining what the test state is, and I don't want the test state to just actually be the default value, so I'm not driving it on you because otherwise all zeros becomes a valid state, and I don't want that to be the test state. So we're going to say let obj equal test struct default, like that. Annoyingly, actually no, we should be able to do it fine because we in theory we can say let new test stir equals string default. Then we can say super component 30 let equal component 30, something like that. You don't know your type yet, which your type is file is new test stir, like so, and then type repo is, and we need to say let new repo equals type registration arc default. Right. Now, here's where the annoying thing comes in. So this makes the thing, and then we're going to say sir dot serialize reflect, and then this will take in takes in obj dot. Okay, so you need to derive reflect. You also need to derive reflect. The idea being that like when you do reflect, everything kind of down the chain needs to also be reflect, because otherwise you can't partially construct something. And then we go say as reflect. I don't know if it needs to be as reflect or as partial reflect, but we're going to go with as reflect for now. Now you're telling me that you don't have this, but we're going to say dot expect to serde, I guess to serialize. Right, and then we're going to assert equal test string and new file test.conf. Right, and then we're going to be like include stir like test.conf. Right. So it's just saying that it doesn't have a serialized reflect function, which is expected. I do feel like I should be commenting you out, like so. Like so. Because I only have this because these are the things that I need to make sure that I implement. Like it needs to be able to have that functionality, I guess, is what I'm saying. I don't know why it's decided that it needs to be indented one, but anyway, we're going to impl component cert t. T needs to impl core. Is it format or IO? See, this format right. Maybe it's format right, but I don't think you can format right into a file. But we'll come to that if we need. So fn serialize reflect, and this takes in self. Probably needs to be self mutably, but we're just going to say self for now because we have a mutable pointer, a mutable reference, which means that I think you can just mutate it. No, it won't let me do it because they're okay. So mute self because you can mutate self, and then object, which is a reflect dyn reflect, right? And then it's just going to be like to do. So you need to return result. You either return that or error, serde error. All right. So we didn't make you immutable, so okay. So we have our repo. Now, I thought there was a way you can, like Bevy has like a weird thing of like implementing all the default, like reflect here, type registry new. This registers all the kind of shit that I'd actually care about having registered, which is all your unsigned or your signed. Oh God, that was loud. 2 different floats. Okay. So, what the fuck is going on with my headphones? Jesus Christ. Stop. Ah, please stop blowing my eardrums out. Jesus Christ. So when we came up to our tests, in our tests, we said you default. But what does you default do? You just derive default. You do, which turns internal type registry. When something derives default on you, your default. So you actually implement default. That's good, I think. So your default calls new. Okay. So you have to explicitly call empty because otherwise it calls new, and new registers everything. So theoretically, that type registry should have all of the types. Now, admittedly, it's going to crash as soon as I do this because it's going to hit it to do. But right, so we need to be like repo dot write. So r dot register. And we should just have to register test struct because it should recursively register everything else. Right. So apparently you don't need immutable. And then we just need to drop r. right. So we make a new type registry. We go to that registry and we just register our type, and then we drop the pointer so that we can, keep access to this. Then we pass it to our component serializer, and then we say, please serialize this object, and then assert that this object matches our test string. So when I hit run, it should panic because it should just tell me that it doesn't actually have any implementation, which is effectively what we want. Because we're going to, So where did it crash? It crashed at not yet implemented here. So we got to here with our object. So the very first thing we're going to do is say, let reg equal self dot typebreaker dot read. Right, get our registry. Reg dot get. So we can get by type ID, but I think that might be a bad idea because something tells me that getting by type ID results in issues with reflected like dynamic types, whereas you want to get by like type name get. The get by type ID, one of these is like get by path. Get with short type path. I think you almost always want to just go get with type path. Short type path is for deserializing because you can use the short path, but we have access to the actual. I mean, technically, because we have access to the actual thing, this would be the most efficient. So it's like, let data equals, what is this, type data. No, it's get. It's not. We don't want the type data. We want the registry. I said get with type. So yeah, this gives us a type registry. So get type info. No. Okay. What the fuck do I? Is there a get with type? So there's get with type path. Get with short type path. This returns T. So this is actually get the type data. Oh no, it's just called get. Okay. Threw me off because I said get data. All right, so we get dot map else dot unwrap. No, it's like map error. Okay. Or, and then question mark. Right. So we have to go here and say that you have an error, and your error is, we can get rid of the whole custom shit because I don't care anymore. Type not registered. And then we have to put something there, but it's going to be like error. The type is not in the type registry. Right, so I have to work out what that is. So we could pass it a type ID, but passing it a type ID would be stupid. So it's going to be SODI error not registered. Can I replace this with a use path, please? Okay. So type not registered, and then cannot find type ID. No, that's because that's object dot type ID. See, that's this. Okay, so it can't be the this one's coming as any, and the issue with as any is as any is going to return the type ID of the actual type, and because of how it works with its like partial reflect, this will return the wrong type ID if you're using a dynamic type, like if you use one of the like dynamic structs and construct a struct at runtime, and then ask for its type ID, it will actively fail because the type ID will be wrong. Apparently, downcast. I thought there was a way to do it, but I guess not. So this is impl dyn reflect. Is it impl try downcast take try? No. I thought into any as any dynamic typed reflect type information. Straight reflect. Partial reflect. So there's get type information. Count yourself any since the downcast reflect should be used. Okay. Dynamic type path send sync get into partial reflect as partial reflect as type mute with apply. Like there's a thing about I guess technically it doesn't know what the type ID is, does it? Oh, it's annoying. There's debug is dynamic. These reflect as reflect. That so I guess what we can do, like as a like to save speed kind of thing, is first off for now, is dynamic. So is dynamic, and we're just going to literally say error dynamic types not supported. Right. Because the way that the dynamic types work is effectively, so we can say something like object.is dynamic. If object is dynamic, return error 30 is dynamic. Dynamic being like basically a struct that's not actually that type, it's pretending to be that type. Like it's been built at runtime with like the same fields, but it's like how you can like update like a single field is you can make like a dynamic type that only has that one field configured, and it's just a hash map, and then it like applies only that one field. So we're going to let the type data equal this, because this is effectively saying what it could do is say if dynamic, then use the type's name rather than its ID, because the ID is dependent on the actual underlying type. Okay, and then we say okay, and then we say type not registered, and then I go something like object.path. Nope. Reflect path. No. As no, as reflect type path. Reflect type path. Do you return something static? I don't think this returns anything static. No. Dynamic type path. Short type path. So T, where T is type path, dynamic type path, subtrait dynamic type path. So these don't return static strings, which is annoying because that means that I. Wait a second. They say they're static here. Okay, maybe they are static then. That means type not registered, and then you can say you can take a static str. You return 0. Is this count? Okay, okay, so it is saying that this may not live long enough. Right, so we would need to do, there's like object dot Type info. Does this return static type information? It does, and then we can say something like path like that. There you go. So reflect the type information, because we already know it's not dynamic, means that this will be correct. And then we can return the type's path from there, because this is static, which means that this is static, which is just a weird roundabout way of going into doing it. But I guess that's why you do reflect and not partial reflect. I guess that maybe this is already safe, because you can't. It's possible that the dynamic don't have reflect; they only have partial reflect. Anyway, so we get to here and we have the type data. So here's my annoyance with it, is that we need to do something along the lines of. Well, I guess it's like type data dot contains by ID data register type data type ID, okay, type information. Is it type information? It might be, because the interesting thing about that is that that implies that because we got to here, which is the dynamic typed, is that a reflect thing? That's my question. Is it reflect that has the dynamic typed, whereas partial reflect doesn't, which is dynamic type path but not dynamically typed? Is that okay? Because I'm trying to work out if there's a way of being like dynamic typed. Since this is subtype of reflect, its methods can be called by dyn reflect. Dynamic dispatch for typed. Where T is typed. Maybe. So that, I'm trying to work. I think that implies that the dynamic ones don't have it, which means we could actually get away with not doing this piece of lookup. But only, I guess, only if it's not dynamic. But anyway, I want to say it's the type info. Oh, we have to work out what the type info is. One of these things is like a struct. Yeah. So if we match the type info, we get access to all this shit here, which means that we can then from there serialize like a normal serialized thing. So we can be like match your type data type info, because the type info will be one of. I actually want to know what the fuck's inside the registry. So type registry, it has type ID map boxed. So this is the type of type. Okay, yeah. So there's just one set of type info, which is just attached to you. Okay, so we can match that, and then we can say do this, and then each of those says to do, and then we get to here, and we say something. All right, so I think I want to go to each of these and say unimplemented. And then we go like end and back. And unimplemented. So the this is another place where AI would be great, because I could like make the AI tell each of these specifically. But anyway, I'm going to assume that it's this one. So then we're going to say that we have an fn serialize struct, which is going to take in mute self. Ooh, that's interesting, because we may have to, since we have a read access here. And then is it going to return this? Okay, that's annoying. So what we may have to do is clone this. So it would be like let reg equals self dot type registry dot clone, and then it would be reg dot read. Right. So doing this means that we have access to our self again mutably, and we can say like self dot serialize struct, and then the struct is going to take in the struct info, like so. And then you are the same, where you're going to be a info struct info. So struct info being a like all the information about the struct. So apparently we have a type, which I don't know what that represents, the generics, and then the fields. So we like basically have all the information we need to be able to construct the type itself. Now we need access to ourself. Theoretically not mutably, but annoyingly mutably, because we need access to the underlying where we're writing the data. So info dot, what can we do? With custom attribute documents field names, get attribute generics. So can we just say like maybe panic info? Comment info. I think that's the way. Like it might need to be debugged. Yeah, right. So we can get to here by going through there, which we can get to either by going through there. So when we run this test, it should panic because we're trying to serialize a struct on the serialize struct thing, which means it should panic and tell us everything that's inside, which is going to be helpful because telling us everything inside means we can like sort of work out what we want to do. That makes sense. Like what information we have access to. My first thing, yeah. So when it panicked, it spat out that it was a polyvinyl SERDI test struct. Its generics, it had no generics. Its fields is name is int. Its type info is hash. Its type is a U32, and its custom attributes is none. Its documentation is none. Its field's name was stir. Its type info was this pointer. Its type is a alloc string, and it has no custom attributes. So and then you get into here, and we say enum b. Its type information. Its type as a test. Its attributes. Its custom attribute is none. Oh, okay. So we have our field names is the combination of all the names. Our field indices is bool is 3, complex is 4, into 0, float 5. Okay, so we have no information, but we have all the fields, which I think is good. So what that translates to is we want to So I'm thinking when we get to like serialize struct, what we want to do is go something like write, and it's going to be this, and we have to write this into self dot. What's a good file? Right. So it's saying that there's no positional argument for this, which is info dot type path, type ID, type. I'm thinking we go type dot crate name, path name, short name, short path. I assume short path is what I want. So this will write this into the file, and then it's going to panic info. I think we want to maybe panic file now. Well, actually, we can just return. Well, I guess when you get to the end, we want to say like write self dot file, and then close, something like that. So I guess you could just return this maybe. You're annoying because you're std format error. Right, which is going to be std fmt error. Something like so. And then it's going to be error. Oh, fuck my ears. No, it's like that. We should probably call this a right error, and this would be a right error. And then we want to say maybe like map error O to TNF, except I want O not to be a function. I guess it's fine. It's like map error, and then we say error 30 error, right error, and then here it is, and that should, in theory, okay. And then I also want to say map error question mark. Okay, so this should theoretically mean that when we run the test, it should return and then panic on the type's name, opening parentheses, and then closing parentheses. So when we come here and we run the test, it should run, and then it should panic with just the type's name. Yeah, so it said test struct open close struct open parentheses close parentheses does not equal nothing because we don't have anything in the file, which means that this is what our current serialized struct will look like. Right. Now, annoyingly, I feel like I want to have like an entirely custom serializer. Because the custom serializer is going to effectively be what lets me pass things in, which is usually why what ends up happening is I don't pass in the arc. If you pass in just a reference to the type registry, as in like you read and then pass in that, you end up in a situation where you don't need to keep a copy because the copy that you passed in is mutable, which I think I do on the next level down because I guess technically the smarter thing to do would maybe make a struct serializer, because then I could pass in the read version here as its own. So go mod and we go mod sir. That should actually probably be its own folder. Legitimately, only reason it meant to be its own folder is because there's going to be a whole bunch of things. So it's going to be like sir, and then in here we say like mods struct vector to name. Sir struct. Right. So then we're going to go like pub use the struct okay. Then in here we have to make a new thing like pub struct. Okay, so structure needs a T, and the T is going to be our file that we put things into. And I guess that's it, isn't it? So it's going to need a file, which is our T. It's going to need a reg, which is a reference to a type registry, because it needs to be able to access other information. It's going to need a It's interesting because it gives me pointers, which implies that I can actually look up certain things. Missing lifetime specify. Okay. So you need to be like A. So you need to type register, and you also need the info, which is also A, and it's a struct info. Right. So you have you, and then we're going to say like impl struct surd, which has any lifetime and t, and we're going to say that t impls, right, no, t impls core format, right, like that. Like pub and serialize. Don't know if that's spelt right, but anyway, it takes. Well, I'm just gonna say it takes in self because that's funny. Well, actually, no. We can say like you don't take in self. You take in a reference to mute self, and then I can implement drop and say again underscore and t, and then where t is core format, right. So we take in our thing and we say like when you get dropped, you can damn, no, that mightn't work. I was gonna say because when you drop it, if it returned the because it got dropped, it'll close parentheses, which I guess kind of works because it's like, oh, it failed. The issue is it's going to return an error. It's also going to drop itself, which means it'll always add the closing parentheses even when it fails, which I guess is technically, like, even if it returns an error, it'll still close parentheses, which I guess is technically what you'd want. So we would want to say something like write closing parentheses self dot file dot expect add closing param. Maybe not. I think that would be like a really cheeky way of always making sure that the drop it always happens, but no, that feels like it's going to result in like the program panics because you rented a file space and then you like it, but instead of just saying it rented a file space, it intentionally crashes, going you failed. Anyway, map error, which is then an surd error, write error. So this needs to return result and a surd error. Right. So effectively you want to do the same thing that this one did. So instead of doing it here, I'm just going to get rid of this entirely. We're going to say that you say surd new, which is going to, again, we're going to go back to not doing this. Let reg equals self dot type repo dot read. Right. So you need to pass in self dot file, self dot repo or reg and also struct info. Right. So that's how that's going to work. So we just need to give you a new. So import a can be an underscore, and t, and I think t is just t. So I don't think you can generic it to anything. You have to still tell it that t exists. Then new, which takes in file t. It should be something more like destination, but anyway, pub file t type registry, which is a reference to a type registry, and also info, which is a struct info, and it returns a self with a generic lifetime and a t. And then you just say self file reg is type registry and info is info. Thank you. So you're complaining because the lifetime is separated because okay. So we need to say that new a t. So you need to live a. You need to live a, and the returned data will live a. Was supposed to return lifetime 1, but it returns data with lifetime a. Fine. We put a here, say a here, and then don't declare a there. No. Lifetime and type generics are not allowed on self type. Lifetime and type arguments not allowed. Okay, so you just return. Oh, okay. I think what it's saying is I can't declare that as being different because I've declared up there. We say new, and then you're complaining because. Okay, so I think we have to like do that, or is it like as ref? Is it dref? There's a way to turn this into a fucking thing. Anyway, so you don't apparently return the right type. Ah, right, yep. Dot serialize. Ah, that's probably smarter. So don't do the new there. Do the info here. So you need a reference to structure info, and then we get your info. Okay, that makes way more sense really, because it means that you could, in theory, set it up to serialize multiple structs. Right, so you take in the info, and then you have to do the thing that the other one was doing. Cannot move self. That's interesting. That should be fine. I think the compiler should catch that and not let me put a mutable reference to a mutable reference in. But it might be safer to do that. Ah, can't be. Okay, yeah. Right. I mean, the other way around that would be to say that this actually takes a mute t with lifetime a. No, that seems wrong. Just gonna hope that it doesn't let me pass in a middle reference to a middle reference. Right. So I don't think, yeah, okay. So we need to be like write self dot file, and then opening parentheses info dot type dot short path. And then return the error. Right. So we go back to our test and run our test again. Our test should pass because our test should effectively say that it like our test should be the same, which is to say like it should just print this. Ta-da. Okay. I guess honestly we should probably start maybe with the simplest concept, possibly, which is to say our tests should have a serialized test. So we're going to be like struct test marker derive reflect. Right. So test marker is going to be effectively that the test is empty. So I do feel like maybe I should move this into a folder so that I can have all like the all the files and stuff in. So this one would be, that's test comp. Okay, so we need a new file. This is called marker.comp. Right, so we go here, we say rename you to mod. Okay, so fn test copy, exactly the same thing, except this is a test serialize marker. Right, so instead of registering this, we're going to say test marker. You compile that, you can serialize that, and then you say marker.comp, and then in marker.comp it should just print the words test marker. Test. Now my question is it going to put the parentheses on it? Because I think I've done this before, and it's like it always wants to put the parentheses because it's like even though there is no data, it technically has data because it's still technically a struct. But I think there's a way, like one of the paths that it can take when it serializes tells it that it's a new type. So it failed, which is a good sign because it means it didn't put the parentheses. So type not registered, test struct. Because we just, okay, yeah, sorry. Test marker. Now run it. I was hopeful for a second there. So I'm pretty sure one of the paths that it can take when you hit this serialize reflect is to tell the reflect system that it's actually just a new type. It just doesn't have any fields. Okay, so it failed because it put the parentheses there. And this is one of those things where I'm like, do I just leave the parentheses? Because technically this is correct, but I also don't like when you go through the code that it fucking test marker open and close parentheses is in your code. So I could do a specific test that is like when you serialize a struct, which I guess is part of the cheekiness of it, is we can go somewhere. It's 30. So we could go here. So it's hitting here. I'm going to say like, because I like the idea of this, we're going to say if info dot field length is equals 0, then write self dot file, and then you just write info type short path. I honestly, I'm annoyed because I want to just be able to question mark these, and the only way to be able to question mark these without having to like map it to a write error is to say that this is a SERDI error. So I could say write error, and then I can go like from. This means that like anytime I format error, like question mark it, the issue is that becomes a this should be a serialize error now because you never read when you're serializing, so it doesn't matter that you should never touch that. Anyway, so this should fix that particular issue. That particular marker should pass because if it's empty, it just prints the name. But we should also add the marker to that, because then the marker will effectively be tested. Did you pass? You failed because test marker does not equal test marker. Oh, have we not got you? Why did you write it twice? Oh, because I don't think we're returning. Yeah, that would make sense. So we're saying if it's 0, right. Then you need to return. Okay. So if it's 0, don't put the parentheses on it, basically. The other way to do that would be to write the name first and foremost. Like you could do this, and then if the length equals 0, return. Otherwise, write the opening parentheses. That is entirely another way of doing it. Technically, I think this would be slightly better because this is less repeated code in that we're basically saying always put the name if the name exists, because if we change like the logic of how we pick the name, which we may have to do, which is like to check to see if there is a shorter name, like conflict, don't put the short name if there's a conflict. Then we spit this back up and go, hey, info field length equals 0, return, okay. Then you get to here. Actually, if it's a struct, because I think, so this is struct info. There's also a like a tuple struct or something as a different variant. So maybe I should be putting curly braces. Interesting. Which I guess is what the point of the tests are, is we want to say, so we can test a marker and then we can derive, reflect, struct, test tuple. Struct, which is going to have a U32, F32, I32. Like so. We're going to impl default for test tuple struct, which is default, which is going to be test tuple struct. Let's go with 2, 4, -4, -8. Right. So this is this tests marker. I am starting to feel like maybe I should have this that automatically registers everything, but then again, like it is interesting to do like test tuple struct default. Tuple. Then you have the test string, and then you do this, and then we're going to register test tuple struct, and then let mute 30 serialize reflect object as reflect expect. Right. What's complaining? You test struct. Right. Marker is test marker, and then I'm going to also again add a tuple which is a test test tuple struct, and then we come down here and we say tuple struct is test tuple struct default. Right there, like that. Okay. So that should give me all this extra information. So when I run this, I'm curious if it's going to pass or not. Technically, you're going to compare a marker, which is fine. So we should probably rename you to struct then, because that would make the naming scheme at least somewhat consistent. So rename tuple struct, and then we should rename you to just regular struct. Right. So I'm just going to grab that so I can paste that in here and say, hey, tuple struct, please. So why did you fail? Because you had, okay, not implemented. That's what I was hoping for, because that means that we can treat tuple structs completely separately to structs, because tuple structs actually go down a completely different path. That's good. Okay. So you need to be struct. Right. So this one checks for struct, this one checks tuple struct. I think I still want the tuple struct to go down the same path, but maybe be given different information. Because I feel like it's just going to need the same things. It's just right, which is going to like mute self and info, which is going to be a tuple struct info, and then return result 30 error to do. Right. So then we come down to, is it here? And then we go here. Okay. So this is serialize struct. And then this is a tuple struct, which is going to be 30 new. So it's going to be a mute self dot file reg dot deref and then dot serialize tuple, and then pass in tuple struct info. Mismatch. You mean mismatch? Oh, I must have told the serialized tuple struct to actually take in the whole thing. I just want to reference it. Right. So my thinking with this is that when I serialize a tuple struct, I don't necessarily want it printing the name of the tuple struct. So that's the pain, I guess, isn't it? Is that like when it serializes a struct, when it serializes a tuple struct, so when it's serializing a tuple struct, okay, so it does the same thing. It writes the name of the tuple struct. So that feels like that should be like a ooh. Like named like this, and then be like bool, and then you would have a named boolean, right? And then you just say named like that, and then we go here and we say if self dot named, because the thinking is that I only want to name it effectively if it's the top layer. So then you'd be the same, where you'd say like if named print this. I think technically you would then you can have like an untupled tupled or whatever, and then we just say write self dot file comma open parentheses, and then write line. See, I don't need this anymore, so I can just dot into, I think. No, that's so annoying. The trailing one needs to be converted. Anyway, do that. Right. So when we serialize the tuple, tuple struct. So the tuple struct will now end up looking like this. This function takes 3 arguments, but 2 arguments were supplied. Okay, so then it's going to be true. True. Because the idea is that when we're serializing something, we've told it that this thing is the main thing that we're serializing. So it needs to declare what said thing being serialized is. But then once we get into that serialization, which is this step, we can basically say, so when we get to here the first time, we say, yeah, you have to tell me what you are, because technically there is a way to infer what it is, but there's no way to infer what it is if it's the actual only thing in the file, basically. But future iterations may know what they're like, whether they're named or not. So I guess the idea would be that if named, and then be like self.named equals false. Because the idea is that, like, in future, false. Like if I go a layer deeper, like if this happens to have a second struct inside of it, I don't want it to tell me what that struct is, because I should already know what that struct is. Anyway, in the same sense, like when we get to here, this is the annoying thing. If self dot, no, if info dot fieldlen is greater than 1, write self dot file new line, bubble that up. So that should mean that we now get this. Well, actually, no, we would get this. Which I guess checks out to me. Right. And then we're going to go... So we're going to always assume we're on a new line, because the idea is that unless there's only one field, if there's one field, I want it to sort of inline it. If there's more than one field, then they're going to go onto each onto their own individual line. So we're going to say for f in info dot iter unnamed fields. So this will iterate through every field, and it's unnamed. Then we say f dot. So what does an unnamed field actually have? So when I go to you and you're an unnamed field has an index, which we don't care about because I assume they're in fucking order. It'd be really weird if I iterated through and they weren't in order. Type info, which is a optional reference to the info. That's concerning. But fair enough. The type itself, which sure. See, that's the concerning thing. All right, so you have access to the type info. You have access to the type as well, which we don't actually really care about. The custom attributes, I don't really know what those are. And then the docs, which again, don't really matter. So by that logic, we can recursively do everything. I don't know. It says it has it, so we can say like if, oh, like let info equal f dot what was it? It was like f no, not you. You type info. Type info. So this optionally returns me static type information. But it returns 9 if the field does not contain static type information such as a dynamic is for dynamic types. Okay. That's interesting because that implies that I don't actually have to pass the type registry down because okay. Map. Okay. Or and then your error is SERDI error. Type not registered. F dot type bar. Question mark. So if I run this again, if I run the tests, if I run this test, and this is what it should look like at this point, this should pass, and it shouldn't throw an error. If it does, oh, I hate that. I very much hate that. Fuck you, Windows. So it said test tuple struct. And well, maybe the carriage return doesn't actually matter because it should have said test tuple struct, but it appears to be saying. I'm hoping that's what it was. It's not actually that was wrong. It's that really annoying if that's what's. I'm gonna hope that it's just that I didn't fix the type name. But it'll be annoying if it says that. Yeah, okay. It's saying that because I'm on Windows, the test struct new line carriage return new line are not the same string, which is some bullshit if you ask me. But apparently, that's just how Windows rolls. I hate that. Oh, so annoying. I don't think there's any way to not do that. Can I go to like the extensions and be like no carriage return Windows? I wonder if there's an extension that just gets rid of. No. It's very annoying because that's going to make writing these tests annoying unless I actually actively put the carriage return in myself. So we could do something like like at the top, maybe declare a macro rule. Be like macro rule load test file, and then that's just going to take in a stir path, which is a lit. I think it's something like that. Like $, please, brain. And then wait, what's it saying? It has to be expert. It's literally the word literal. Okay. A literal. I think strings count as string literals. And then we can say include. So you get include stir dot replace. Well, let's do it down here so that we can like get it to do it with the type thing. Dot replace backslash arb backslash n to backslash n. Then you copy this, you go up here and you say do that, except this is $pat. Then we come down here and we say, hey, test this, replace that with that, and that, and we go, is it gonna work? Maybe. That should hopefully work, because it'll go through and it'll replace every instance of the carriage return with just a new line. Which should make it not care that the carriage returns are there. Okay, yeah, now it's passing. Cool. So next is to actually paste the data. This is where we start hitting recursive shit, because I need you to if index if f dot index. All right, that's just a thing that I can ask, is does not equal 0, write self.file. Right, so if the index isn't 0, write a comma. Same logic, if the index isn't 0, it should be write a comma and then a new line. It always assumes it starts. It's always assuming that it's starting on a new line, but then it's saying, hey, if I'm not 0, then 0 is the new line, so write a new line. Then, okay, so we have the type information. Here's the annoying part. We need to you're a type info. So we would need like a it's like a mod info router. Which, I mean, kind of makes sense. And then like pub use ser info info ser. Then we have to create you, and then do like pub so you have a T, and then T is file T. Brian, come on. Right, so you have a T. So pub struct info cert and T, and then file T, and then, I mean, technically, named boolean. I'm gonna see how far I can get without giving it a fucking type registry. So can I just like entirely remove type registry from you? I want to see how far I can get without the type registry. I think you may only need the type registry for deserializing, because you shouldn't be serializing shit that has dynamic stuff. It's going to be a little bit annoying that I'm removing all these lifetimes. Actually, maybe don't do that until after you can make a commit. What are we going to say? Okay, so we're going to come here. Now we're going to remove them all, because it means if it doesn't pan out, we can revert back to here and have it like not have to be fucking forever to get all these lifetimes back in. Okay, get rid of the type registry entirely, your type registry entirely, because if I can get away with not having to pass the type registry around and just say that like if a struct requires the type registry for some reason to be serialized, it just can't be serialized. It's not an acceptable way to serialize something. Why are you saying? Because you don't have a lifetime in T. Alright, then we go back up to here and we say you don't serialize this bit. Which would actually mean that theoretically we want to cut this out. And we want to say type. We want to go like sir. Info sir. New. Self.file. Comma true. Let mute. And then like sir dot Siri type data dot type info. Something like that would be what we'd want to do. So now we have to go to you and say that you impl info sir t fn new, which takes in a file t and named boolean and returns self, which just says self file named. Right, and then we just need to say that t exists, and then impl where t is core format right info sir t fn serialize. Don't know if that's spelled right, probably not. Anyway, we'll fix that later. Pub serialize, which returns and result 30 error. Then you do this, and we'll work on that. So you take in mute self and info, which is you return like a type info. Like that. Right. So you take in your type info and then you just match info. Like so, and then you go like, you're like super please. Okay. So you do that, which means that your way of doing it. So is that just how I spelled it everywhere? Is that how it's spelled up here? Then we go back to study info and we go serialize. Right. So we can call serialize, and then serialize will call the corresponding appropriate thing. The main reason for doing this is because we effectively need to go up a layer. Because when we come into here, so you call this and you say new is private. So you actually give that this. Right. You give that your mutable file because you're behind a mutable reference. Okay. So we stick you in there. And then you come down here and you pass your mutable fucking file into here. Right. So you pass it to here. And then we get to here. And we go, hey, here's the info that I want to do. So I need to say let ser equal super info study new file. So yeah, self dot self dot file. I don't know if the compiler is going to catch this, or I'm going to end up with like an infinite fucking chain of dereferencing file pointers. But anyway, and then self dot name. Now it should be false because at this point we said hey named and then we pass in false, which means we don't even need to update this. But yeah, anyway, so we could go to here and we say da 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 da. We say your file super info study we have that, and then we go dot serialize, and then we pass in info, and then we bubble that up. Now this should panic because we haven't done something like implement to opaque. So we serialize a tuple, and the way we serialize a tuple is we serialize the unknown field. If it's the first index, we just serialize it. If it's the second index, we write a comma and a new line, and then we add the information. The idea being, I think you just put the comma. Damn. This seems a little silly, but anyway. So it'll, if there's more than one field, it'll put a new line. Then it'll go through every field. If it's not the first field, it puts a comma and a new line. And then after the final field is done, if there was more than one field, it'll put a new line. The idea being that that will be what pushes the comma down so that this ends up on its own line. Now, when I run this, it's going to probably fail, or almost certainly it's going to fail, because we haven't implemented the opaque. And the opaque's technically the most important, because opaque is the one that does the fancy bit of every like underivable shape is opaque. So what did it spit out as its error? So the idea is that like integers are opaque because they're effectively saying that you can't store or reflect about them because they are so. Yeah, so it's saying mutable reference to string does not implement format right, which is annoying. Where is that coming from? So my thinking is that that implies that you up here, where is it? This one? 30, this one. No, it is this one. This one. The you get to hold the file, but every subsequent drop down has a mutable reference that lasts a. And then you return self a. And this needs to be a mut t. Saying I can't declare a lifetime here, probably because it's declared up there. And then we don't declare the lifetime here, and then we just say a. Okay. So again, okay, and then you get to be underscore because you don't actually care what your lifetime is. There we go. Right. So you now don't have to do this. Now, that's the annoying thing. I think I have to like mute dereference. And then same here, is if you like mute dereference. So effectively I'm like going down the pointer and then referencing the pointer where the pointer went. Compiler should clean that up, but it does mean that like we don't end up with that stacking type anymore, and then you have to probably be the same. But maybe not. I would actually, no, I assume you do need to be the same. I don't know, we'll find out. So see if it can compile this. I'm assuming it's going to run into the same issue of saying like, hey, you can't pass in a reference to a string of a string. A reference to a reference of string. Yeah, recursion limit. Okay. That or I've fucked something up somewhere. Because it is saying recursion limit. Where is the recursion limit reached? Yeah, okay. So it requires that, that requires that, requires that, requires that. Yep, okay. So we have to go back to you and say that you do have a lifetime again. So dash A. No. Dash A. And then you are instead a reference of dash A that is mutable to T. Same thing here, dash A. Dash A. You are a dash A mute T, and then you pass that in, and then you are a dash underscore comma. Because I don't actually care what your lifetime is. Right, which means that you will still work, and then we don't have to recurse indefinitely to 255, saying that a mutable reference works. Okay, so then we can come down here and be like, run. Nope, still doesn't like it. So what are you saying? Reach the recursion because you don't dereference that. I would have thought I could call like self.file.as like surely I can just call deref mute on this. Anyway. Let's try that. So we're gonna go back to tests and gonna run this and go, hey, you gonna compile this time? All right, well, it got there without crashing the compiler, so that's a start. It didn't pass, but that was expected because I haven't actually updated what it's supposed to say. Yeah, so it got to here, which is serialize, reflect, opaque. Now, the fun thing about serialize, reflect, opaque the fun thing about serialize, reflect, opaque. This isn't the hardest thing to do. We up here and we go mod ser info copy spelling opaque. The thing with opaque is that you effectively have to do it custom for each of the potential types, I guess. So we go this, and then again, pub use ser opaque ser pub struct opaque ser opaque. So this needs so a t file which is a mute t. They really don't need to be split up like this. They could all just actually be the same thing. That's actually kind of interesting because I did just realize that theoretically, like, you have serialize, which takes in an info, but there's no reason that I couldn't say like, can I go like info impl super info the underscore comma t where t input or t is core format, right? Well, opaque, which just takes in mute self, and because if I can get it to not have to keep nesting, that'd be kind of nice. This serialize struct, and then info is opaque. Go back to info. It's called opaque info. Import reflect opaque info. We need to be a reference to you. You need to return a result, comma 30 error to do. Because, like, theoretically, we have a middle reference to itself and I have a middle reference to itself. The issue is that it touches the data, not the thing. So, like, can I go here and just say, like, self dot serialize opaque info? That seems to work, which means we don't actually have to keep making these new types every time we want to, like, do something, which will be incredibly useful. Now, this would be when we would actually need the type registry, my understanding, because theoretically we could match on every single type and implement our own potential, like, you're a serializer. I mean, there's no reason not. Because you could be like, is this, is that, but it makes, like, significantly more sense for you to have access to reg, which is the type registry. Right, and then I think I have to make this like pub to super, so that, you know, the super can get access to all of it. You need to live for A. And then you have the same thing. Which is the type registry. Reference to the type registry, like so. And then except we're just gonna go like paste that there, get rid of that, and go, okay. You also need to live A. Alright. That should let me like propagate the type registry all the way down. Now you're gonna have a problem with it because, okay. But same idea. We're gonna say fuck this off. And we're gonna implement this for super info, sir. And then this becomes, instead of an entirely new thing, you say self dot serialize info. Question mark. Okay. And then this doesn't exist anymore. So then this is the same, where you become, instead of that, you say self. Right. And you also become self. Lovely. And then instead of being info, right, and then you need the registry, which is going to be reg.deref, comma, this. And then you say self that serialize type information, and you pass that up. All right, so we serialize a tuple, and then we get okay. So this should get all the way to serialize opaque. Now, my annoyance with serialize opaque, and the reason I added the type registry back in, is we need to say what info does the opaque have? It literally just has the type and the generics, because what it's saying, like, so a container for compile time info related to reflect opaque types, including primitives. These typically represent a type which cannot be broken down any further. This is often due to technical restrictions or by definition, but it can also be a purposeful choice. For example, I32 cannot be broken down any further, so it is represented by an opaque info, and while string itself is a struct, its fields are private, so it doesn't really so we don't really treat it as a struct. It is therefore makes some sense to represent it as an opaque. Now, what this annoyingly means is that we do have to like effectively check to see if it has a method of serialization, and then put it in with its method of serialization. So it's like let reg equal self dot registry dot get type data info, and then the type data is like reflect serialize. See, Bevy has a reflect serialize. I don't even know what it does, but anyway. So we reflect serialize. And then it's info dot type ID. See, and this type ID is different to the other type ID. So we get that, and then we're gonna, I guess, I'll map that into an error later, but the idea is that I just want to get to here in terms of crash. Okay, reg dot fine. Map. Okay. Or 30 error. So we need to grab the word opaque. And then we have like opaque not surdy. Then we need a static stir, because again, if by the time we get to this point, there should be no dynamic types. We shouldn't be able to get here as a dynamic type. Error. Does not implement surdy reflect. Now, technically, it should probably check this at all levels, but anyway. Does not have reflect serialize. Where's it called? Technically, it's not that. Anyway, where's our errors? Error. So you do this, and then you go opaque, not serialize, and then we go info dot fucking da, and then go to the end, go to the question mark, and then we go, hey, so registry doesn't have anything. Registry has a serialize function, which does something. I don't know what it does, but wait a second. You don't actually have any data. We haven't been passing the objects down. I mean, fair enough. Okay, so hub from serialize, fn self value reflect serializer. Now I feel like I want to use ron as the method to serialize the base object. Again, at this point, I might as well just do it myself. No. I think at this point, because I'm going like, oh, we can just ron serialize. But the idea with that is that like, I'm no longer like collapsing everything. But I guess I am still collapsing everything, aren't I? The idea is that when you hit this point, I'm effectively falling back to saying, hey, like, do you happen to have a way of serializing yourself? If so, I'm happy to serialize you that way. That's interesting. Well, because the trick with that would be you'd pass a serializer all the way down. Because this is saying S serializer. So registry, serialize, and then you pass in value and then the serializer. Which is an interesting... So instead of file, you pass in serializer. I'm curious if that would work. Like, if I replaced the T with instead of being right, it was I don't think this works because I don't think I'm allowed to touch the serializer at that kind of level, but we could say so again, we need to be able to somehow get the fucking object all the way down here, which we don't have at the moment. But we're going to say something like so I would want you to pass the serializer all the way down. I don't think ron lets me do that. I don't even think I have access to ron because it's not part of my crate yet. We'll just quickly chuck in ron just to see if this works. I don't think this is going to work. I think I'm going to have to make my own thing, maybe? I don't know. Serializer new. So writer, which is then going to be self mute self dot file dereferenced and then none. The question is, does that work? They'll expect to work. I want to know if this works, but anyway. So now we have a mute T. And then we say serialize, and then we pass in sir, the serializer. Cannot find value in scope. Yeah. So we would want to pass in let t equal 4, and then be like t dot as reflect, right? Because you're saying that you need a dyn reflect, and then you should just return OK. So are you complaining that serialize is not implemented for t because ty? What does Ron need w? It just needs format right. So you are actually a Ron serializer. But why does it not, where w is format right serialize, or because it needs to be a mutable reference. Just a wait, that fucking worked. Okay. Expect Ron to work. Like, what is this actually going to print? I wasn't actually expecting to get this far, because the idea is that I could theoretically check at every stage if the particular type that I'm hitting has reflect. If it doesn't have reflect, go and serialize each of the individual components. Basically, did I run the test? Did I not run the test? I don't know if I ran the test. It failed. What did it print out? For reflect failed when called by type on type with the value 4. Wait. From reflect. Downcast T, map, serialize borrow, else T from reflect from partial correct value, map owned, box, new value, else. From reflect failed when called on type U32 with this value 4. Excuse me? You're saying I'm not allowed to turn from reflect value 4 I don't understand why it's crashing, because like it's telling me that something tried calling from reflect. So ser into serialize opaque. Then we Bevy reflect, type reflect serialize, serialize, reflect mute Alex string. Reflect call once closure, reflect, closure, panic handle. It's saying it can't convert a U32 from a U32. It's unclear. From reflect failed when called on value U32. I guess technically this is an I32, but I can't see that being the fucking case. That'd be really weird. Why? Wait, what? Am I passing in the type data at some point? What do you fucking mean? Who is calling this? Oh, that's what's happening. I'm grabbing this reflect serializer, which is not actually matching the type that I'm passing in. So we have to get the value all the way down here somehow. V. So serializer opaque, which is going to be V, and V is dyne reflect. Right. So V has to get to here, which means that V has to come in here. So V, which is dyne reflect. Right. Then we have to pass in V here. So what it was yelling at me for is I was trying to use an I32 to convert a U32. And then it was like, oh, well, now you're trying to convert a float because I'm still passing in those. Right. So where the hell is V? So this is we are iterating the field. An unnamed field. I don't think we're doing that right. Yeah, you still don't have, so you need a V, which is a dyne reflect. Right. So you are the reflect. And then we get to here. And so we can say info iter fields, but it's not that, it's V dot. No. Okay, so info dot iter. Right. Can I say that this is your type information? And then can we say let V equal V dot. No. As reflect, but it's already as reflect. As any, as in a partial. Reflect ref. Reflect path. Is there a reflect path? So you're going to return me a dyne partial reflect. That's fine. So you need to pass me a reflect path. I don't actually know what a reflect path is. Something that can be interpreted as a reflection path in get path. Do you have an example, perhaps? No. Can I just pass in f dot index, perhaps? No, apparently not. Okay. Okay. Bevy reflect path. I need an example, please, of a reflect path. So can I say format dot f dot index? The trait string reflect path. So wait, you need to impl reflect path. But apparently string doesn't impl reflect path. It has to be a const then, I guess, would be my guess. Okay, so static string. Okay, so what the fuck impulse reflect path? No, I want to go to the actual trait. What the fuck implements you? But what? So it's implemented by a reference to a string, but not a static string, just a reference to a string. What's the other thing that implements you? Parsed path. Okay, so there's this parsed path vector offset access. No, what? Implementations. Second implementation. This parsed path. Named field, unnamed field access. Sequence access. Field index access. None, some. Access struct field at index 0. So I think it's a parsed path that we want. So import that, and then it's a vec like that, and then it's a, what did you say they have to be? Some kind of offset access. Okay, so offset access. The character offset in the string the path is passed from. That's optional. All right. Okay, so access field index f dot index, and then offset is none. Okay. Wait, so you return an option, right? No, you return a result. That's interesting. What is your result? I mean, I can just return that, but you're going to tell me something, right? What is your return type? Path result. Reflect path error. I don't like that this immediately gives me a limitation on my fucking error life thing. Path error. Now, I think I can just say static. Path error. Like path error. Can you just qualify this? Yeah, I'm assuming you're going to have a problem somewhere. You need to pass in v, which is object. Right. We will continue with you. So we get this, we can pass that up because apparently this is static, which I think has something to do with the fact that this string is static, which is good. This method takes 2 arguments, but 1 argument was supplied. Yes, okay, so we need V. Right, which means it needs to be a partial reflect, not a full reflect. Okay, that's fun. So you are actually partial reflect, which just gives us less control over like exactly what information. So it means that like theoretically, so serialize requires it to be a reflect. No, that doesn't like that. Okay. How do I turn you? I can try and downcast you and try and I can easily turn you as partial reflect. Reflect module path, reflect mute. These are all partial reflect. What does a reflect ref give me? This gives me another partial reflect, which is fun. Okay, V. What? Try as reflect. Attempts to cast this type to a fully reflected value. Okay. Dot map. To okay. Or I'm assuming you just return, yeah. Not full reflect. I kind of do want it to be like, so it's gonna be like error cannot be cast to full, which I assume is a dynamic. So like the dynamic types, but again, by the time we've made it to opaque, we already know that you're probably not a dynamic type, to be honest. Self struct, right. These are all being parsed in reflex. That's fine. So we go here and we go, okay, are you okay with this now? Kind of. You just need to question mark that up so that this is the right type, and then cannot convert error type 30 error. So not full reflect reg dot no info dot type path. Right. So we get our full reflect here, then we try and use Ron to serialize the full reflect. Because we come up to here. Okay, you're the issue, and that's because you take in this, which means you need to take in like a partial. Well, actually, you take in the partial reflect, but I'm going to say that actually, when you get to here, get rid of this here. Turn you back to being a full reflect. I think we need to go one layer up. So you'll stay reflect. Where is the error? One layer up. So you get V. Where do you get V from? V comes in as partial reflect. No, I'm going to say that it has to be a full reflect. Which means that should push our error one layer higher, because I'm now saying that this is actually just you pass in V. The error should have been pushed one layer higher. Right, U. Temporary value dropped. Okay. I'm going to say it's something like paste this here, and then reference to P. Well, you're saying, can I not just give you P? No. Why are you saying that P may not live long enough? Okay, P does not live long enough. Borrow value does not live long enough. P is borrowed for static. Who says that you're borrowed for static? That's my question. Who says you're borrowed for static? So if I get rid of this and this, you no longer borrow for static? No, you do. If I put this back like this, temporary value dropped while borrowed. Why do you need it to be static? Do you borrow for P, path result for P? It's probably because I'm casting. Okay, right. It's here because I've said that this is static. Now, what do you actually need the lifetime for? Pass for error A. Fine. That won't work because it needs to be in. Okay. Right. So I need to like convert it to a string or something. We need like 30 error and go, hey, you pass error, which is just going to be a string for now because I can't be bothered dealing with the lifetimes. And then we're going to come down here and be like, you. So you're saying I need to implement parse path for the sturdy error. I'm going to be like import into no, from this for so that's going to be self path error format value. Qualify. Okay, so now I can convert So implicitly performs a conversion on the error value using the from trait. That's what I've got, right? Oh no, it's partial path. Reflect path error. That's what, okay. There we go. Then that lets that convert to you, which then lets me convert you and you, which lets me serialize you with the info. So that should mean that when I run the test, it actually gets all the way and effectively finds the serialize for F32, I32, float. All those have serialization now, which means that they should all, in effect, spit out the information that I need. They still failed, but what did it actually come up with? It said invalid access error, kind, incompatible types, expects struct, actual tuple struct, field, index, offset, none. Okay, so you're saying that when I'm in a fucking tuple struct, we can't access it that way, which means that it's a different type of thing. So it's not a field index, it's a tuple index. F dot index. Okay, which is a little weird because I would have thought that a field index and a tuple index would be the same thing, but anyway. Let's delete you. Let's go back to here and go. Okay, do you work now? Ooh, we got something. So it says that. Fuck that. It said that it's put out a tuple struct and it said 2, 4, -8 new line. So new lines between everything. So that means that the tuple struct looks like this. 2, 4.0, -8. New line. Got it. So if we now run this again, because we've now corrected our save file to look like what it's supposed to. It passes. This is what it's outputting. Now I do feel like I should probably check a little earlier in the sequence to whether it should or shouldn't serialize things. I also feel like I have to do like a special bit of serialization for things like entities and handles, because again, you need to like actually save that somehow. But like in theory, what about the other one? I guess technically what I should do is set up the file to be like, what should this look like? This should look like if we go here, it should effectively look like this. Let's put this in. So you should look like this. Again, we're not going to have very good grammar, but mostly because theoretically matching would be the same. So you should say something along the lines of, so you should be like string, float, true, So then you should be complex struct. Complex struct would then be probably something like this. And then I think you're just the same. Well, actually, I don't know what the complex struct's default is, but we're going to go, you should look something like this, and we'll just like ... because I haven't actually worked it out. Test enum should say B. Okay, and then it should say test marker. And then it should say tuple struct I would want it to be like that, maybe, and then it would be this tuple struct. So where it says tuple struct, paste this. So it should say that. That's what it should look like if it works properly. So let's see what our no, serialized marker should work fine. Yes. What are you going to spit out? Because you should just work. Come on. Right. So the test struct doesn't actually do anything, and then this is my file. It's still got carriage returns everywhere. Oh, because you don't. Yeah, so you don't include string. You should like load test file, whatever it is. Load test file, and you also should load the test file. But anyway, so that's what it's supposed to look like. It doesn't look like anything at the moment, but that's because we haven't actually updated the struct. So this is what it does. Again, we print named, self name file, right? Set that to true. Right, so that's for doing a tuple, but this is for doing a struct. So we should print the name, then do a curly brace. I should have double because it's a format thing. So then we print the curly brace. Then same thing again. If there's more than one field, I'm gonna say greater than 0, so it only does it. It'll always put the fields on new lines. The curly brace is only gonna be like that if we don't. So if there's any fields at all, put a new line. We then we have to do this, but instead of being, yeah, okay. So we go info iter. I feel like I should be doing this as a dictionary, but anyway. If f.index does not equal 0. So if f dot, I don't think these have indexes. So we're going to say like let mute first equals true. So if not first, if not first, do that. Right, then let info f dot get the information for the type path. field index. Okay. I f. So then we get to go back to this and be like I not equal 0. We don't have to do the first thing, and because we go field index I. V. You don't apparently take in V, which is fine. So I'm going to say V is a dyn reflect. Right. So we say let info, let V, and then we get the field index I, and then we say V, turn this into a reflect, and then self serialize V. Right. So we have to write self file, comma, and it's going to be like this, right? And then we need to put in the name, which is f dot name. So now when I need to not debug this. I need this to be normal printed, but anyway. Is there something I can select? I don't think so. Sorry, yeah, you get V2. Thank you. Is there a way to... I don't think so. Presumably, I think there's something like... test string and... marker dot complete. Right. That might work because that should, in theory, not. What am I trying to do? Close this. Well, didn't do it anyway. It's not the marker, it's you. And then you'd be tester and that should work in the because I've given it a special format thing that doesn't debug it. It shouldn't print new line carriage return shit all the time. It should actually print a pretty string and be like, this does not equal that. Right, it threw some kind of error saying something wasn't implemented. Right, which is insert info. We said that enums are not implemented. Okay. That is a very valid point. Okay, so fn serialize enum. So we need to copy this, paste this, rename enum, and then it should say test enum b. Right. So I mean, test struct is fine to be the thing that I register. No, it needs to be test struct, because that should, in theory, register the enum as well. And we're going to say test enum c, I guess, which means we need to go modify this and say that it should say test enum c. So repo register serialize reflect object to serialize enum. This is a test, thank you. Okay. I think the harder part's actually deserializing this shit because it takes a lot more work. But anyway. Okay, so when I call test enum, we're gonna have there, I'm gonna say, okay, we need a new module. It's gonna be mod ser enum. Right. So we go to info here and say there is only one enum, as opposed to how we have struct, tuple, and tuple. Honestly, I feel like I should move the tuple struct into the tuple and then have the tuple automatically call, like tuple struct should call, the tuple struct should print the name and then call tuple. It's the same as struct should call the name and then call map. Should print the name and then call map. But anyway, we need to take all of this, paste it here, and just say serialize enum, which takes in a reflect and an enum info, like so. And then again, we don't really know what's in enum info, so reflect serialize, so enum info. So type variant names, variant indexes, variants, variant info. So that's my thinking here is well, I copied like out of all of them the worst one to copy, but the idea is that if we go to like 30 struct, so we go, hey, if name, print the type path, and then just return OK. Now, okay, so I don't know what this is, like added repeat. Right. So we go here and we say, okay, so we reflect V. So we say, hey, if name is turned on, print the name, turn the name off. The idea being that, again, like if we're unaware of what we should be, we should print what we are when we serialize. Right. And then I think the way that we want to do is we want to say, v dot, ooh. It's something like v dot reflect ref. So it's like let you return like a reflect something. V equals or like else panic to do I guess to do I'm getting tired, that's why I'm doing to do's. To do v So you should never be able to get to here because we've already checked that it is in fact an enum. We already have its fucking data. Reflect ref enum e. Right, like data. Right. So this is how you do, like, we say, hey, this is my reflect type, and hey, I want you as an enum type, which means that I can now ask it questions that are specific to an enum, like variant, maybe? Variant name. Variant index. Don't actually care. Variant name. So we would say variant name. So it's like self dot, I don't know, it's write self dot file, comma, colon, data dot variant name. What is this variant type? Oh, that's probably the thing. Okay, yeah. Name. Variant name. So first thing it does is print the name of the variant. Then we say match self dot data dot variant type. Right. So if it's unit, we literally do nothing. We just go okay, and then we can go to this. Right. If it's a tuple, we self dots. Okay. I don't know how I extract. Because we would say we don't have it. We haven't done that, so this would be a to do. And then the struct would be self dot serialize struct, and then we'd pass in v and info. But again, to get v and info, we have to somehow work out how to say like data dot. So the variant index, variant type, variant path, variant. So how do I get access to said? Is variant, is dynamic, iterative fields. Current variance fields. But like my assumption is that like, does it not represent? Well, I guess you have to go to enum and go to like enum. Be like, hey, field. Div field, which we can get a field by name, field add. Get represented enum info. Variant path is variant to dynamic enum. Variant name. Iter fields, field length, at index of field mute, field I feel like it's a bit weird that like I know that it's a struct type enum, but I can't pass it as a struct. So enum info, variant info. So how do I get access to the variant info? Hmm. So we print the variant name. It's a little bit annoying that it's like this because I'm going to be like equals get represented enum info. That's the represented enum. I don't care about the represented enum. As enum. Oh, okay. So as enum. Yeah. See, like you can't like as struct. Maybe you can if you get to like the enum struct info. So how the fuck do I get that? So with the enum with enum info, I can variant name variant. Okay, so we can say it's because we already have the info. So it's let info equals info.variant, which is data.variant variant index. There's no point like double like map looking up. So we're going to say variant at. Dot expect this variant exists. Again, I gotta just make sure that this fucking works. Okay, so it's like, hey, get the variant info. So what can I do with this info? We already know that it's definitely a tuple variant. I mean, maybe we should match on the info at variant at, because that would then get me my variant info. Anyway, as tuple, as struct variant, dot expect is all struct. Now, my question is, does the v dot so we have like fieldling like as field docs, field length, field names. I don't feel like the struct variant info. Why is this different? Right, I'm just going to quickly copy this. We're going to go to struct. And like, the fuck? Struct info. What is different? Named fields. Index, custom attribute, documents. So this one has a name, whereas this one has a type. And that's it. That is the difference. Which annoys me because it means that I can't make my code work with both of them the same way unless somehow you also, as struct, like I don't think you implement dined struct. So we have a new with docs with custom new, a new. Case sensitive, please. Like, I don't think there's a struct. There's variant info, and then there's struct. Your struct. Your struct. Wrong struct. Yeah, so there doesn't appear to be like, because there's like a trait struct, and the trait struct would theoretically allow me to say that instead of taking in a reflect, it takes in a Stein struct. Oh, it's so annoying that they're actually just like ever so slightly different, which means that they will need custom implementations. So we have serialize enum. How did I get that? I said info variant at expect. All right, then we're gonna do this. Okay, so variant name, So if it's a unit, we say write self.file unit variant info. Wait, is it variant name? I think it's more like you write your name, : then it's so type dot path and then variant name, which means that you actually do just return. You just return okay. The fucking tuple does like pub serialize. Well, I guess that's the point. It's like serializing the map. If I call it serialized map, because if I can make this generic enough to accept that, then I can pass in the other one and then it should like work. So you would take in mute self and map, which is an array of named field. I'm going to call it name struct too. Fields, which is an importer. Item equals named field. I feel like I need extra information, but maybe not. Fucking no point. Right. So all of them put their fucking name. So when we do that, go struct, these don't implement name. If length is equal to 0, return okay. Don't do that, please. Okay. So you need to return a result 30 error. I am getting so tired. I need to stop for the day. All right. So if fields dot okay. Honestly, just always do a new line? Fine, comma new line, else. Right. Just new line, please. Just new line. Theoretically, I could just do the new line here, I think, because I think it doesn't matter. Like, if we're saying everything always has a new line, then what you're really saying is if it's not 0, put a comma. If it's not the first one, put a comma. It's not, so it's fields. And then we say fields enumerate. We say if you're not 0, put a comma, get the info, bring this information in, and this information. Right, you're annoying, but I assume that I can access V here. V. I assume, not 100% sure. What do you mean you don't reflect? Anyway, I assume that I can access you with the reflect path like that. We access that using a field index. Then we say V try as reflect, and then we say serialize V. Right. File F name, and then we self.serialize. So why are you saying that? So you're saying no method named reflect path for dyn reflect in the current scope, this trick. What have I imported in struct? Because I'm pretty sure struct just takes in V for you is just reference to dyn reflect, which implies that I haven't brought something in that I brought in otherwise. So type reflect. Maybe it's just because this is happening. So we're going to say self.serialize struct2. So you pass in V, which is you, and then you pass in fields, which is going to be struct variant info dot iter named fields. Oh, sorry. It needs to return references to named fields, apparently. It needs to annotate a lifetime. No? Okay. What do you know? Hmm? No, named field's not good. Okay. Named field doesn't have a lifetime. What are you fucking bitching about? That this doesn't have a lifetime. Alright, so then this says struct fields, and then for some reason you still don't think that reflect path exists. You've brought in reflect. What am I not bringing in that I'm bringing in here? Like you're dyn reflect, and then you're like, hey, V is dyn reflect. Parst path, offset access, get path. It's almost certainly get path. Wait, not you. You. Okay. So you need to bubble up, and then we need to serialize info. So this is serialize struct 2. So the idea being that like when you serialize a struct, so actually, we should rename this to serialize fields. And the idea being that we pass an iterator to the fields. That's how you serialize a struct. You put the name of the struct and then you iterate the fields. Otherwise you put that, okay. So that should work. So then when we go back to enum here, I'm going to do this as like a multiple test thing. We're going to say test enum s. Wait, it should be test enum struct a to b 10.0. Right, and then here we're going to say test enum tuple 3 15. Alright, it'll be like, okay, the exact formatting is a little bit annoying that I have to actually copy the exact formatting that I'll end up using because it's not actually comparing that they're the same, it's comparing them to the string representation. But without a parser, I can't like parse them in, parse them out, which is what you would normally do. I'm explicitly testing that they serialize properly. So test enum, so we have ABC, and then we're going to have struct, which has an U32, or A, U32, B, F32, and then tuple, which will have a U32, F32, like so. So there are different variants and whatnot. So what we need to do is say when we serialize enum, I need to serialize reflect object object. So object will reflect C, and then dot serialize reflect test enum struct 2 10 as reflect dot expect to and then tuple, which is then 3 15. Oh, now it's not probably gonna look quite right. Honestly, it's probably even one of those, put that like that. All right, so we serialize C. Yeah, the issue is I like can't exactly push multiple things in, but when I run this, it should at least vaguely look like, and then I can just tweak my comparison file, because again, the comparison file is more about knowing that it'll actually like render somewhat close to what I expect. So what did it spit out? It said serialize enum panicked at 30 info serialize reflect. Right, because you need to say self serialize enum v and enum info. All right, now we try that again. We rerun this and go, please actually get to serializing enum. It's probably going to again panic at the fact that I haven't implemented the tuple. I should probably get rid of the tuple entirely, because it's going to say, hey, not yet implemented, which is annoying because it's like, well, I need to make sure that the other shit's doing what I expect, which it should be printing test enum C and test struct A B. Right, so it spat out test enum C, test enum struct A B 10 newt line. All right, so let's look at the fact that it didn't newt, and that's fine. And then test enum tuple. That's mine. Okay, so one thing it didn't do is new line the final struct thing, so that's a fail there. So we're to go to U. So when you serialize fields, one of the things you need to do is when you get to here, So it always prints a new line, and then we're going to say if honestly, just always print a new line. So struct name curly brace, new line curly brace. Right, so that should give us this, except annoyingly, you shouldn't have a comma after the no trailing comma. Right. So we go here and go tuple struct. No, So annoyingly, there is no new line. I mean, we could always new line. Like nothing's saying we can't new line. So to kind of to replicate this, so no trailing comma. That's what it should look like, which is effectively what it's doing, except it stuck these on the same line because I don't have a trailing comma, which is to say, it's going to be like serialize info. So you serialize the whole thing. So you call serialize on a struct. You could, yeah. So when once you've serialized any num, if I call serialize again, so that means it's kind of like here that we're going to be like write self dot file or you just right. Trying to think if it's one of those, like, does the end of every struct want to do it? Like, does every struct end up on a new line? What's that going to end up looking like? So we have serialized fields, which again is like a struct thing, which we should also serialize named fields. Right, which is what a struct does. So it's like, hey, prints this, and then it serializes the named field. And then struct does the same thing, where we're going to say when you come in here, I want you to self.serialize the info. How do you do this? You say so. Yeah, basically in here we say everything between the sets of curly braces is self dot serialize named fields v comma what do you need? Info dot header. So that should make you do what I want you to do. And then we effectively just needed the same thing, but with the tuple. Makes me think this should probably be somewhere else, but anyway. Serialize tuple. Everything here is serialized tuple. Okay, so then that should just call self. Why can I not fucking spell? Self dot serialize fields and then info dot header. Right, and then we come back to here and we say get you all the way down here. Get you here. Oh, please don't tell me. Control C something. Okay, thank you. That's terrifying. This is unnamed field, we say here, we say hey, right opening parentheses, if field length is greater than 0. So again, feel like because we don't have access to that, we just want to be like so it's fields iter enumerate. Why can I not? Oh, because you can't call iter, it's just called enumerate. You can't iterate an iterator. Enumerate, which is then I comma f, then it's if I equals 0. It's not equal 0, put a new line. Yeah, again, we just kind of need to make it match. Wait, you don't... Oh, okay. Okay, otherwise just write a new line. And then when you get to here, you just put a new line. Well, again, just out of laziness, we're putting a new line even if it's empty, so I don't like it, but there is a way to be like, fixed, like there's like a, you can like ask the iterator how many elements are left. Sizing. So we can do that to work out whether like it's going to be longer than a certain length and therefore whether it should be one line, but I feel like that one's more like right line. Let trail equals field dot size int dot 0 is not equal 0, and then if trail right I guess right line, and then else. I'm gonna do that, and then put this up here. Do that, and then you go. Okay, so we can serialize the fields, because the issue is I have no way of knowing kind of like how long the fields end up being. But the idea with that one is that the where is it? Struct. So in this struct, we either serialize named fields or we serialized unnamed fields. But like they both do the same thing, and the same with the enum. Have I implemented that yet? Serialize enum. Oh yeah, we have to also change this to being. Oh no, it's already a tuple index because I copied from the other one. So then you, my friend, become self.serialize fields v and iter. Right. So that should in theory, when I rerun this, when I do the I probably should have turned on that one. So again, stop you, rerun you, and I close these. So this should mean that structs and tuple structs are handled the same way, and the same as tuple enums and tuple structs are handled the same way. And when I do tuples, they will also be handled the same way, which again should make it more consistently the same. So it said that they failed because effectively I'm not putting a new line in. Otherwise, they look effectively identical. So my annoyance with that is that serialize enum. I don't think you should be the one putting a new line in because issues. Because like it should be a comma then a new line. So it's effectively like you guys shouldn't be doing this new line. Which again, the great thing about this is it's going to affect both of them. You don't do a new line, cool. So neither of these are doing the new line. The new line has to come from somewhere else. I'm just not entirely sure where. Because well, I mean, the simple thing to do would be to go and say that the new line doesn't exist because it's something else's responsibility to put the comma after. But then when we serialize this, it may actually pass this time. I'm not entirely sure. I might have messed up somewhere else in terms of like exactly how things combine, but okay. So they still didn't think they're quite identical, which is that something's got spaces. Okay. I think in my example I put spaces. But other than that, it's looking pretty identical, to be honest. Okay. I would say that they're the same. It's just that something's got spaces somewhere. Is it this one that's got the spaces? Enum, do you have spaces? You have spaces. So apparently, there's not supposed to be spaces. Now they should be identical, and something's got a new line at the end. The one with spaces doesn't have a new line? Wait, so you are putting a new line then? That would be enum. If trail, new line, comma, otherwise no new line. Oh, because you're a right line, so. And so are you. It should be right. There we go. Right. So that should make them the same. So now I'm curious what my omega struct will look like. What is it missing now? Be able to run my struct test. Not my tuple struct. I think that one already works, doesn't it? Okay, serialized marker already works. Serialized test. Okay, so serializing test is saying that it failed because left, which is what it should have looked like, does not equal what it did look like, which is to say test struct. Oh. Okay. Well, struct is just apparently not working at all then. Why are you a curly brace? Wait. unless I wrote in my example wrong. Okay, my example is definitely wrong. So my example says curly brace. Curly brace. Yeah. So it spat out test struct curly brace 10. So again, I've got spaces. It's one of those weird, annoying things about like because how I'm doing it. True. Complex, and then the complex says 0 empty false, which I'm going to say is actually 100% correct. That is what complex is supposed to say. Then it says enum b is b. Okay. Really, I should be fixing it the other way so that it actually does do the test thing. Right. Then you said marker and then said nothing. Okay, why did you say nothing on marker? Interesting. I think I told it to do that, which is just fun. Then this, yeah, this should actually just say this. All right. Now I'm going to break everything by adding that naming back in. But then this should say da 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 da, and apparently this is like a new line thing. Right. So I skipped this for some reason, which is interesting. I need to make sure that it adds the name even if the because I can't retroactively get it to not include the name. I don't think. Yeah. I guess I could, because I could just say like if it's a unit struct, just don't print it anyway. Okay, so we need to go like to enum file somewhere in here. So we serialize files. I mean, the obvious thing to do here is to go at some point we write the fucking name in, don't we? No, this is unnamed fields. In here, we write the name and then we just put the spacebar back, which is going to again break my example because I just spent all that time not doing that. But anyway, we have test struct. So why is it not doing marker? My assumption is because marker writes literally nothing if name's turned off, which would be in like when we say serialize struct. The struct. When we serialize a struct, we say, hey, if name's off, don't. If name is on, print it. But then we're going to say, hey, if the, so what we can do is go like this, which is a little bit annoying because it does that thing that I was talking about. Self.name. Right. Because this is basically saying if the length is 0, print the name no matter what. And also say that you've printed the name and return nothing. So the idea with that is that no matter what, you'll print a name when it's a marker. It's a little bit weird because theoretically the marker being in unit struct can't not exist. So this is redundant information and really just shouldn't be serialized. But I don't really have a way of doing that. There probably is a way of being like, hey, if there's no fields and it doesn't have a name, just fucking don't. But I feel like that would result in information getting consumed. And again, I can't not print its name without extra steps to specifically not print its name. All right, so let's run this again and see what we get. So serialize the test. There's obviously still a bunch of shit that's not getting done because if we go to info, we aren't doing tuples, lists, arrays, maps, sets. Okay, so this says that, yeah, so we put all the spaces back. Lovely. All right, so let's go tidy up the struct component. So it went something, something, something. So you stayed the same. It's you need a space, you need a space, you need a space, you need a space, you need a space. I think complex. Nope. You need a space, you need space, you need space, you need space. Comma. B test marker, yes, and then yes, and then done. Okay. So test struct int struct int. But as long as you don't use a list, an array, like a vector, this should be able to serialize effectively any type because it just keeps recursively going down until it hits. So it won't be able to do components because I believe they're opaque. Maybe not. Names again, like there was a thing that I did where like names technically also for some reason serialize their hash, which I fixed in my previous implementation of this when I did it for a different project. But like you have to have like custom serialization for certain things, or you end up like serializing metadata, which is kind of weird. So serialize struct, serialize tuple, so first off, you have to be serialized tuple struct because of the whole, you are actually a separate thing from serializing a tuple. Now, the fun thing with this is that we can effectively go mod ser tuple. And this should be like really easy to implement because we can just go enum, I guess AC tuple, paste the tuple stuff in, keep the serialized fields. I think we get rid of the serialized fields in the enum because I feel like the enum having them isn't necessarily wrong, but like the idea is like I would expect to find them in the tuple folder, not the enum folder, because effectively that's what they are. So there's this serialize tuple. The fun thing with this is there's tuple info is that the tuple is effectively just going to say self dot serialize fields v and then info dot getter, right? Because that's just what a tuple looks like. And then we have tuple done. So we get to go back to does that mean that other one doesn't have an example of a tuple? The mega struct doesn't have an example of a tuple. Oh, good job. Info, pop info open and go, hey, so tuple, which is then self dot serialize. Fuck, that was loud. Right. So we serialize the tuple info. Now, I'm not entirely sure what the difference between a list and an array is. I assume, like programmatically speaking, an array has a length and a list is growable. But like, in terms of like what the difference in data is, I guess that's the point. I've got a list, I can say, hey, list info. Let's go array info first. I'm going to copy this, and then we go back here and go list info and go, hey, what the fuck is the difference between you two? You both have a type of generic. So an array just has a capacity. Right, that's literally the only difference, which means they both can do the same thing. Now, I don't think it's going to work because they're both going to... Wait, and double check. Lists, generic option type. Yeah, okay, so and lists, so they both can only hold one type. The only difference is that an array is effectively forced to have the same... an array has a capacity, that's it. That's the difference. So I guess we go here, we go mod, so list. Oh, array. Right. So the array, so again, I think we're just going to copy this, paste it in, go, so the array, and then we go, okay, so when we serialize an array, we're going to do something, and then we're going to serialize something, and something. Right. So this is going to have array info. Interesting. Expected result. Yeah. Okay. So he's gonna say like to do, because they both need to call into like serialize. Where is it? Where is my like main thing? Is it up here? No, it's like one layer higher. Then I was hoping it would say sequence. Okay. Anyway, serializing a sequence. So you should just say self.serialize sequence v and info dot try. No, like what the fuck do, so the type. Ooh, it's interesting. Okay, so maybe I have to turn you into a specific iterator. Interesting. I don't quite know how I would do that. Anyway, so we're going to say serialize sequence, and then you're going to say serialize sequence. And then you're just going to pass in v, I guess. So for now, like sequence isn't going to have any information. I don't like that because it like loses some amount of information. I guess we should just say info dot what was the thing? So array we can call, it's called an item info. Item info, which then returns a optional type info. I feel like we should also send in len, which would then be info dot capacity. Well, I have to call it len here. So then this would say item, which is a reference to, would you return me a static so it doesn't have to be static, just type info. You send me type info and info and len, which is a usize. Right. So first thing, you write this. Then for I, in 0 dot dot len. If I does not equal 0, write a comma. Okay. Right. Then we say that the info, we already have the type info. That's interesting. Okay. So then v would be access. What? Why are you now yelling at me? Expr. What are the access types? List in, so we have field index, tuple index, and list index. So list index I. Okay. And then we would say, hey, V, try get V as an actual reflect. And maybe item. Type path. Then we say write file. We write the new line. And then we... Oh, okay. So we write a new line. When we get to here, we write a new line. And then we self.serialize info. Item. Passing in V. That should work, I think. So you're saying that serialize sequence, no method named. Have I changed how I'm spelling? Okay. Serialize sequence. Right. So you're saying you can't do that because this is an optional thing, which is going to be, again, for now, expect. Reflect. Okay. So result. Mismatch. Okay. We should do that. So when we serialize an array, we pass in the capacity and we say, hey, do that for the capacity. Now, the list one will have to require an extra step to convert the reflect to get the length of the list. So what I'm curious about now is when I say test enum, I should actually be able to say let enum equals an array of test enum, so test enum C, test enum struct to 10, test enum tuple 3 15. Right, and then I should be able to say, hey, just reflect enums.as reflect dot expect to work. So now when I run this, it should actually put each of these 3 enums into their own array, which is obviously then going to fail immediately because it's going to stick the square brackets around everything. But we can go to enums and we can say now it should be like square bracket, comma, enter, comma, enter, square bracket, right? Because that's what it should have spat out. Ooh, type not registered. Well, that's a pain in the ass, but okay. I mean, I can do that because the idea is that. Well, you can tell me that you can't reflect. Maybe. I mean, it is entirely possible. R.register poly. Oh no, it'd be an array of test enum by 3. Alright, so apparently that is perfectly fine to register. Admittedly, I would probably want to try a vector, but for testing an array, we test it with an array. Okay, so something serialize is not implemented, which is to say we didn't tell it to serialize array. Okay, self.serialize array with v and array info. We should probably do the same thing with a list, which is this, and be like serialize underscore list. Okay, and then we just go to array and we say pub serialize list mute self v, which is dyn reflect info, which is a list info, you return result, nothing, 30 error. Then we say like self.serialize sequence the item. So item would be info dot item info dot expect item is reflect. Then to get your len. So to get your len, I think we go like let reflect ref list L equals v dot reflect ref else panic non list passed to serialize list. Right. So that gets us out a list, and then can we say like L dot len? Ta-da! Right. I also you should be list info. How did I fuck that up? Anyway, list info. To make sure that we test this, we're going to go, hey, can we also do this thing again? So copy like this entire thing. So after you've asserted that, do this. We want to I guess do this here. We go, hey, redo this with a new test. We're going to say tester.clear. And apparently, I guess we just clone you. Right. So we're going to do this, but this time we're going to do it with a vector. And we also need to make sure that we say vec of test enum. All right. So this should check the list. Checking it twice. So effectively, we run it through once. We make sure that the array spits out the same value, and then we run it through again, and we make sure that the vector spits out the same value. Now, it didn't quite work, but by looking at it, it's like it's not working because of why are you not? You should always be printing your type name, shouldn't you? Wait, no, because you say C if it's known, right? So that's a little bit of a weird, like, and there's more to do with the fact that it's in a file, maybe. Well, no, it's more like my thing's wrong, right? Because there's my one that's not saying it every single time. No, mine says it every single time. The correct code only puts it out on the first one. Which is interesting. Okay, that means, like, I guess effectively go to enum. Serializing enum should only be like, it should be if name is true, and then when name is true, don't like clear name. Now, my issue with that is I feel like that's going to result in the enum. Well, yeah, it's effectively like when you print an enum, don't decide that you don't print names anymore. I could always just make it always print the enum's name, because I think that's technically correct. But I like the idea of it being able to, like, hey, see. All Right, so now did it succeed? So it said asserted that left is not equal to right, which is that it said test C, yep, and it said test enum. It didn't put a spacebar. I have a spacebar. Is that it? This doesn't quite line up, but I think that's because of this one fucking space. One fucking space in my here. No spacebar. So if I rerun that, it would probably be better not to have it include the file and instead load the file, because then I can modify it without having to recompile everything. But anyway. It's still panicking. You're the same, you're the same. Does my example not have spaces? I mean, it's entirely possible. It doesn't. Okay. Please run the test on enums. And this should, theoretically, nope, it's still not the same. Did I not put a last? I didn't. I put a curly brace at the very end. No. Square brace, square brace, square brace. Oh, I didn't update. Yeah. So this is what tests are about. I didn't update you to put a square brace at the end. Okay. And honestly, I may have to call it for today because I am getting so tired. But we are very close to it effectively being able to recursively do anything as long as all opaque types that are used implement reflect, or implement serialize. So the idea is that if you implement your own type that does its own thing, it would need to serialize on its own. So my example is I'm pretty sure handles are considered opaque. Maybe not. But I'm going to have custom serialization for handles and for entities, because again, you have to map the entity to relative space. Otherwise, you end up with this situation where you're like, oh, well, it's going to use entity 360. And it's like, well, that doesn't exist anymore. It's a different thing entirely. So it needs to be able to map it to local space. But anyway, that test pass. Can we go to the top and be like, run all the tests and go like, hey, what are the odds that, hey, all the tests are passing? So we can serialize a marker. We can serialize a tuple struct. We can serialize a test, which is me trying to do kind of everything. So what we can't currently serialize is like maps, because again, like it's pretty obvious when you come into info. We can't serialize maps and sets. Now, I feel like maps will have to be done on their own. I don't know, maybe we'll look into what the actual info is inside them. So key info, value info. Okay, so maps do need to be done on their own because they don't have their own. Yeah. So, but there's no reason a set. I think sets, I don't know how they're done in like RON, but like theoretically a set is just a list. So set info. Value type. Wait, why are you different? So T set. So this is the type of the set, and this is the type of the value. And it says it has to, T value has to register reflect. But why are you not keeping? What? Am I going insane? Like, didn't array info? So I think that's just a bug that nobody's noticed, because it doesn't make sense that why would sets be special that they don't include a method to get Huh. Yeah, I think that's not supposed to be how that works. All right. That actually makes it so much harder. Really? That's just got to be a bug. It's kind of hilarious that it's doing that. Because what that boils down to is theoretically you could say that a set is done by saying self.serialize array, but say set. Then we like v and set info. We have access to the like set information, so we can just like pub serialize set, which takes in exactly the same arguments except it's set information. And again, you do exactly the same thing, except we're going to say reflect set. Now, the serialize set. So you don't have item info, but can I say like L? Well, L, apparently you have an iterator. Really? Where your item is partial reflect. Values in a set. That implies that the values have to be the same anyway. Dot. No, not what we want. Like, what exactly can I do with this set information? Like, nothing, right? We can just get the value type. That's kind of it. So, but what about like, yeah, what does set give us access to? Get, which gets a specific value. It is empty. It'll drain, retain, to dynamic set, insert boxed, remove contains. Right. So equals, and it's going to be something like self.registry.get so get type info, and it's going to be info dot item value type dot id dot okay or surdy error non for reflect is dynamic path, so type not registered, and then that would be info dot value type dot path, and then we bubble that up, and then we can say that this is your info. So I guess we can do this instead of expect on all of these, which is fine. Info there you go. So if you fail to get the item info, report that that item doesn't have info. Type not registered. I don't entirely know if that's would work in the generalized sense of it could be in the registry but not in the data type for some reason, but I can't imagine where that would happen. Anyway, so this should let us print sets now. Now, I do have a feeling that, like, again, in Ron, like, a set's supposed to be in curly braces, not square braces, because it's technically not an array. It's a map, and it's a map of no value type. But that also seems dumb. Why not just store it as an array? It's up to the person to know that if they put duplicates in it, that it won't actually load duplicates. It's not like it's going to check to see if you accidentally wrote duplicates. It's impossible to have duplicates in a set, so it's just an array of unique values. So I guess we add that to our omega test struct. So we say you need a set, which is going to be a hash set of platform, and then I guess we call them enum. Well, we can let's go like I8s. That seems like an interesting thing. And then can we be like set is hash set from, and then an array, and it's gonna be like 0, 0, 0, 0, -1, 1, 10, 15, -2. Right. So, ooh, that could cause issues. Just with how I'm doing it, because the order is indeterminate. 0, 0, like there's no guarantee that it'll actually be in that order. So this is going to fail because set's not even in on the list, but so we get to go down here and we go like set, and then set should be something like this, and then it should be something like this, and then it should be like 0, 1, what did it say? Serialize test kind, ooh, list index, offset none. That's interesting. So I can't index into a set by our index. So it kind of makes sense, to be honest. So sets are going to have to be treated slightly differently then. That's annoying. So I guess leave that the same. So there's field index, tuple index, list index. A signature element accessed within a path, multiple accesses can be combined into parts of the process. So the trick with that one is this is going through them in order, I guess. So I guess serializing a set is we'll just treat it as a map then. So we go like up here and we go like mod ser map. We could make them their own entire thing, but again, I feel like it's more like just do a map. So we need this. This is the actual serialization code, and then I feel like it's just going to be like this. Paste this in, and then move this into here, and we go okay. So instead of having serialize this and this, so this would be SERDI map. So you, at some point, I guess, yeah, you would just have a serialized set, and then you would just do exactly the same thing as serializing a map. Okay. So you do this, which is to get the info. Then you do this, and you have access to the info. But instead of doing that, we're going to say for, and then it's L dot iter, right, which gives us a dyne partial reflect. So the very first thing we need to do, yeah, we can enumerate these. because it just gives me back my eye. I don't think I use it for anything, but anyway. So I don't think we need to do this. What the hell is wrong with my fucking headphones? Jesus Christ. Stop. Okay, it's not gonna... Okay, weird. So, yeah, curly braces, because it's a set. And I think that's how you indicate a set. I actually don't know. But, yeah. So, item went from somewhere. So, not fully reflect is V. And then V type path, which means we don't have to get... Well, no, we do have to say V to V. Not fully reflect. Are you gonna let me do that? Probably not, because I think you need it to be static. And it's gonna yell at me that it's not static. Where do you get your info from? It's just called info. Yeah, okay. So can we say info then? Okay, so it's saying, hey, this item is not fully reflect. Other ways we do that, and then we just stick it on the list. So that means we go back to our struct here. We say set. So a set does this, and then we say 0, 1. What were the other numbers in the fucking set? I actually don't know, but anyway, we'll fill it in when it actually complains. So we're just going to say to do on the serialized map because, yeah, extra work. So info. Alright, let's go back to map. I keep fucking changing the name, spelling of everything. Serialize. Anyway, so serialized map is going to work like exactly the same. Except we're going to change this to map. Non-map. Pass to serialize. Map. Info. I don't think you need a lens. So, okay, let's start. Info. Map info. I don't know how I fucked that up. Anyway, info type registry get. Do you happen to? Okay, so you do tell me the two fucking things, which is so this is key equals self.registry get type info. No, not that. It's info dot key info dot okay or info dot. I don't know if I can do that. That's also not even correct. Type not registered. Key type. And then val. Okay, so then we write, let's say self file curly brace, and then we say, hey, enumerate u, which is going to give me a something like kv, and then we say, hey, if index is not equal to this, then write your little comma, and then we say try, so this is k, and then v. So can you write? Oh wait, it's on the other side of it. So new line, wait. Do you write that? Then you serialize key. You serialize k with key, and then you write and then self.serialize v with val. I think. Why do we not use k? Because k, no, v gets cast. We're casting v into k and then v into v. Right. Blah, 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 and then you not fully reflect, except this is dot key type and then dot value type, and then it's like path. Right. So we get the key, I guess, which is going to be more scuffed, which is going to be less scuffed. Write the key, then get the value. Make sure that they both can be done. Who knows? Okay, so this should let us do hash maps and the sort. Why are you complaining? Because I, yeah, right, I know why. I didn't make it a reference to it. Okay, so that should then allow me to go back to my like test thing and be like, okay, so it should be 0, -1, 1. Copy this, and then we're gonna say map, but there's gonna be a hash map, and then the hash map needs to be tuples, I believe, which is gonna be like 0, 1. No point duplicating anything. -1, 2, 1, 3, 10, 4, 15, 5, -2, 6. Okay. You have no field named map. Yes, but you are going to in a second. Map, which is a hash map. Sorry, map of this and this. I8, I8. Aha. And then we go back over to our like struct composition thing, and we say, hey, this is what our set needs to look like. So it needs to be. Now the issue is that it's going to be somewhat random. It might not be completely random in that, like, if the numbers are deterministic. I want to say it was 1. Like if the numbers are deterministic in the hashing, it will result in the same hash map each time. So you'd be 3, and you'd be 4, and you'd be 5, and you'd be 6. And then we need to put them on new lines. That's the annoying thing with like doing it in this file format, is that it is in fact testing my patience. In that I have to match the shape of the data exactly. Once I get it able to serialize and deserialize, once it has the ability to deserialize, I don't need to worry so much about the exact shape of the data because I can serialize and then deserialize. So when I run this test, it should serialize the map and it should serialize the set, and then they're going to end up kind of funky because they serialize in a certain way. But then I should be able to reorder them, and then hopefully that would result in them being the same because the hash should be the same between runs, but I'm not entirely sure if that's how that works in Rust. So mine says no, see, it's like 10, 15. The fact that they're different between the two sets makes me think that that's not how that works. Anyway, so I'll just compare it by which is that it says 10, 0, 1, 15, -1, -2. And it's like 0, 1, -1, 10, 15, 2. Yeah, okay. And then 0, 1, -1, 2, -1, 3. Oh, that's mine. 0, 1. They don't have spaces between them. But yeah. So 0, 1, -1, 2, -1, 1, 3, 10, 4, 15, 5, -2, 6. Yes, okay. So it's printing it out properly. It's somewhat shaped the right way. It does need a lot of formatting, but I am legitimately so fucking tired right now. And then we have to make sure that this gets bubbled up. And that should let us theoretically serialize anything that's not opaque. As I said, anything that is reflect but isn't opaque, which is as long as it doesn't touch entities, entities. As long as it doesn't touch entities, component, and like handles. I'm not even sure if handles are opaque or not, but yeah, entities. As long as it doesn't touch entities. Because like theoretically, like an entity's going to yell at me and say doesn't implement serialize. Possibly. Even if it does implement serialize, I need to have some kind of way of like converting it to the correct spatial thing. The test struct. Okay, so we just want to say like entity. Something like that. Entity. Whoops, not you. Okay, so this should fail. It's like a placeholder, right? So I think this is max. I'm just gonna run what I know will crash, partly because I don't even know what the placeholder entity value is. Yeah, so it's not non. What the fuck? Okay, cool. I'll get that number then. By like running the tests. So this should fail because. Should it fail early? I don't know. It's going to tell me that the opaque isn't implemented. Like that reflect that entity doesn't do reflect. Maybe I don't know. Actually, I have no idea when it's going to get to its issue. So it's saying, hey, it doesn't match. Well, that's interesting because that implies that it did actually manage to serialize that it's entity 1. Well, I don't think any reflection is compiled on reflection. That's kind of the point of reflection, is that it allows you to do compile like type interactions at runtime. But it is done like if you derive reflect, all of that can be done statically is done statically at compile time. From what I understand, like I haven't really looked into how Bevy does it, but like it will automatically register all the types you depend on. Like when you see down here, I'm only reflecting these, registering these because these are different types technically than the underlying type, and I actually are using them. But when I register test struct, I only register test struct to, or I guess this is a better example in test. I only register test struct, but test struct uses the complex struct, the test enum, the test marker, the test tuple struct, the hash set, and the hash map, which all need to be registered independently. But when I register test struct, it goes and registers and makes sure they're all registered properly. But it does it at runtime, like in the it has to run at runtime, or you're not really doing anything. But like, as much of it does do with like when I derive reflect, this is a compile time macro that goes through and works out which of these need to be reflect, which are not reflect. So like I couldn't put a field in here that's not reflect. Like I can't, I don't actually know any fields there. Can I just be like window? The issue is that like, a lot of shit in Bevy is reflect. So like if I went like window, well, I actually make something kind of struct. So EX is not reflect because it doesn't derive reflect. So if I say like EX, it's going to tell me that EX doesn't implement reflect. It says like you can't derive reflect because EX doesn't derive reflect, and so to do that I have to like derive reflect. I can do like derive reflect like that, and that would add EX as one of the like that's now EX is now a marker struct, and my thing will automatically save it. Or I can say reflect ignore. I think that's how you do it. And so that says that wow, fuck my headphones. This says like reflect. This isn't actually something that you're supposed to be able to see. Like it might be like bookkeeping or metadata that's not actually relevant, or like in this case where it's like you couldn't reasonably reflect that type, so you just say don't include it. My code I don't think will even know it's there because mine's again relying on Bevy to tell me what types are there, so it just effectively skips over this. And now it's only complaining because I don't have it in the default. So it's saying, oh, I can't make it because it's not actually default, but like that's unrelated to the reflection. I don't know if that answers your question, but I really need to end the stream because I am so fucking tired. But thank you all for tuning in. I will hopefully continue this tomorrow, where we will be I guess working on the deserialization. I'm entirely unsure how entity got turned into one, but sure. Apparently when you serialize the placeholder entity, it just becomes entity one. But yeah, thank you for tuning in. I will see you tomorrow.